Hi and welcome to the course Python for Nuke here on Rebelway. My name is Simon Jokuschies. I'm a senior 2D pipeline TD and the founder of Kregel Visual Effects tools. In this course we'll learn how to apply Python inside Nuke to create tools with a clean code base. We'll gain a solid understanding of Python and we'll be creating many tools over the next couple of weeks. But we'll start from the very beginning so everybody can follow along. Over the course of the weeks, we'll then increase the difficulty and speed, as I'd like to show you also some intermediate and advanced techniques like how to structure your Python packages, creating APIs, and the model view controller design pattern, just to name a few. So let's have an overview of what we're doing within this course. So this course is split into 8 weeks. In the first week, we'll have a look at how to use Nuke ScriptEditor and start off with some fundamental concepts in Python like simple variable types, container types, how to iterate over these, list comprehensions, and also how to use if, elif, and else structures, just to name a few. In the second week, we continue with fundamental concepts like functions, classes, and inheritance, but we'll then start diving into the Nuke module and create Nuke-specific things via Python, like creating and accessing nodes, updating knobs, and we'll also discuss how to use the init and menu py, and so on. And we'll also create our first small tools that paste your node clipboard to multiple selected nodes and add functionality to bulk disable nodes. In the third week, we continue tool development and create a node aligner tool. We deal with error handling and concentrate on Nuke's event-driven mechanism. We also discuss the downsides of using knob change callbacks and why you should be careful using them. And based on that knowledge, we'll then create some event-driven tools. The fourth week is designated to customizing Nuke's user interface. We'll learn how to create custom menus and commands. And we'll have a look at a round trip for creating a gizmo from scratch and register it to Nuke's user interface. We'll enhance Nuke's backdrop node with presets and have a look at reading and writing various file formats from and to disk. In the fifth week, we'll then switch to an integrated development environment called PyCharm. We'll have a look at package structures and we'll discuss how to structure and build a toolsets manager in a clean and structured way. Weeks 6 and 7 are designated for the implementation of graphical user interfaces. Now there are 4 different techniques to create these in Nuke and we'll have a look at all of them. During that we'll create several tools with graphical user interfaces to see how this all comes together, and we'll also add graphical user interfaces for tools that we've previously implemented. In week 7 we switch over to PySide, which gives us the most flexibility for graphical user interfaces. We'll discuss all necessary components like widgets, layouts, and the signals and slot mechanism. We also discuss the model view controller design pattern, which is key to creating decoupled and sustainable code that can be easily extended. In week 8 we'll use all this knowledge to create our final product. We'll create a graphical user interface for our previously created toolsets API so that users can browse, create, and execute Python toolsets. We'll wrap up with some final tips and tricks how to further improve from here. Now this course contains a lot of practical examples and shows you how to apply all of the various techniques you learned. So that after taking this course you should feel very comfortable creating your own Python tools inside Nuke. Now I've been working as a Nuke compositor for 5 years, but switched to the technical side of things in 2017 and have been working full-time as a pipeline TD since then. So this course is taught from a pipeline TD's perspective. I'll put some focus on showing you how to create clean and sustainable code. One thing you will see me doing is to ensure that the code we write is clean and documented, because this is really key when creating software in a professional environment. Alright, we have a lot of things to cover, so grab a big cup of coffee and let's go! Hi and welcome to the course Python for Nuke here on Rebelway. My name is Simon Jokuschies and I'm a senior 2D pipeline TD and the founder of Kregel Visual Effects tools. In this course, we'll learn how to apply Python inside Nuke to create tools with a clean code base. We'll gain a solid understanding of Python and we'll be creating many tools over the next couple of weeks, and I'll show you many different techniques. But we'll start from the very beginning so everybody can follow along. Over the course of the weeks, we'll increase the difficulty and speed, as I'd like to also show you some intermediate and advanced techniques like how to structure your Python packages, creating APIs, and the model view controller design pattern, just to name a few. So let's have an overview of what we're doing within this course. So this course is split into 8 weeks. During these weeks, we'll get a solid understanding of how Python works and how it can be applied in Nuke, and we'll create several tools for Nuke. But before getting up to speed, we'll need to learn the Python basics, which we'll tackle in week 1. Now, these are the fundamental building blocks for everything upcoming, because before we can start running, we need to know how to walk, right? So to implement some awesome Python tools in Nuke, we need the required Python basics and need to understand common techniques and terminology. So after discussing some backgrounds and having a look at how to use Nuke's script editor, which we'll be using in the first half of this course to stay in a known environment, we'll then learn several Python basics, like how we can print something to the console, how we can use single line and multi-line comments. We also learn about simple variable types like strings, integers, floats, and booleans, how we can use format strings, and also learn about container types like lists, dictionaries, tuples, and sets. And we also deal with list comprehensions. So this is a really great feature to create a list from another list. Then we'll have a look at how we can loop over container types. And we'll also tackle how we can use control structures like if, elif, and else. In the second week, we start applying Python inside Nuke. But first we need to continue with some more Python basics and learn how to write functions and classes. And we'll also have a look at inheritance, as this will become important later. We'll then learn how to apply these concepts to Nuke by using functionality inside the Nuke module. We'll be creating nodes and see various ways of how we can access nodes and also how we can manipulate nodes and knobs via Python. We'll handle how and when to use the init py and the menu py so that we can then also set knob defaults. Now, everything we've learned so far gives us then a very good and solid base, and we can then start building our very first tools. But we'll start small with a tool to paste our node clipboard to all currently selected nodes and how to toggle enable and disable certain node classes in our working file using Python. In the third week, we'll develop several smaller tools inside Nuke. We continue our journey with some more Python basics and learn about the standard library and have a look at some common error types, when they are raised and how to deal with errors, and also how to raise errors yourself, as this is a very great concept that lets you drive how your code will behave under certain situations. We'll then build an aligner tool to align selected nodes horizontally and vertically. We'll also cover Nuke's event handling callback mechanism and create our own tools based on these events and discuss why it is not a sustainable idea to use knob change callbacks and why you should be very careful with these. We'll create event-driven tools to execute several things once a render has finished and also create an auto backup tool of our working files. Now the fourth week is designated to customizing Nuke's user interface. So we'll learn how to create custom menus and populate it with submenus and commands and add everything that we've developed so far to Nuke's menu bar. We'll have a look at a round trip for creating a gizmo from scratch up to registering it to the user interface. And we'll also enhance Nuke's backdrop node with presets and have a look at reading and writing various file types from and to disk. In the fifth week, we'll then switch to an external application called PyCharm. Now, this integrated development environment is really powerful and contains lots of useful functions to better develop larger software projects. So after a quick tour of PyCharm, we'll then implement all follow-up tools in this IDE. We'll also have a look at how to run it with Nuke's internal Python interpreter so that we can effectively implement for Nuke, but outside of Nuke. We also have a look at package structures and will discuss how to structure and build a tool in a clean and structured way so that it can be easily extended. We will then discuss some concepts for a larger tool that we'll be creating throughout this course, which is a toolsets manager. Because I think besides creating small tools, it is actually quite interesting and important to see how larger tools can be implemented using a clean architecture. And for that, we'll start discussing some requirements for the needed structure, and we'll then be implementing the API, the so-called API, which is the application programming interface, so that we can then save and load toolsets via code. Later in this course, we'll then wrap a user interface around this tool. Now, week 6 and 7 are designated for the implementation of graphical user interfaces. There are 4 different ways to create these in Nuke, and we will have a look at all of them. First, we'll have a look at some basic functions built into Nuke to get some user input. Then we'll have a look at nuke.panel and create some simple windows with some common widgets. We continue our journey with using nukescripts.python panel, and during that we'll create several tools with graphical user interfaces to see how this all comes together. And we'll also add a graphical user interface for tools that we have previously implemented. We also have a look at how we can dock a widget. We also have a look at how we can dock a nukescripts.python panel to Nuke's user interface. In week 7, we switch over to PySide, which gives us the most flexibility when it comes to creating graphical user interfaces in Nuke. We start simple with a small PySide window, and we'll then have a look at the most commonly used widgets and how to add them to a window using layouts. We'll then explore how to make our windows interactive by using signals and slots. We cover how to style widgets to give them a unique look. And we also discuss and implement a tool using the model view controller design pattern, which is key to creating decoupled and sustainable code that can be easily extended. So in week 8, the final week, we'll then use all this knowledge and create our final product. We'll create a graphical user interface for our previously created toolsets API so that a user can browse and execute Nuke and Python toolsets and can also create new ones. So this will be a longer series of lessons then. We'll then wrap up by discussing additional features for our toolsets UI and best ways how to tackle these. And finally, we'll cover some final tips and tricks how to further improve from here. Now, there will be assignments at the end of each week so you can practice what you've learned so far. We'll then discuss how to implement the assignment then always in the beginning of the next week. Now, this course contains a lot of practical examples and shows you how to apply all the various techniques you've learned. So after taking this course, you should feel very comfortable creating your own Python tools in Nuke. Now, this course does not require any Python or programming knowledge. You should, however, feel very comfortable with Nuke's user interface, and using Python will then start from the very beginning, but this course will become more complex over the time because I want to show you also some intermediate and advanced techniques. Now, I've been working as a Nuke compositor for 5 years, but switched to the technical side of things in 2017 and have been working full-time as a pipeline TD since. So this course is taught rather from a pipeline TD's perspective. So I'll put some focus on showing you how to create clean and sustainable code. One thing you will see me doing is to ensure the code we write is clean and documented, because this is really key when creating software in a professional environment. Now, it is also important to understand that in order to create great Nuke tools inside Python, what's really key is to have a solid base understanding of all the fundamental concepts and putting some efforts to create clean and sustainable code. Now, this is what I'll put definitely some focus on in this course. Because if there's one thing that I've learned as a pipeline TD in the recent years is that there is actually a difference between creating tools that work and tools that work well. Now, getting tools to work is actually not really the hard part. So smashing something together with barely understanding software architecture and making it work, yeah, that is fine. But you know, if things are poorly designed and don't follow a good design, and have also deep coupling and are hard to extend, that is not really hard to work with. That is not really fun to work with. And oftentimes these are then the tools that will oftentimes not get any update and will eventually be replaced over the time. Whereas if you have a good solid understanding of Python and software architecture, you can create tools that have a clean code base and are well structured, well documented, and simple to read and easy to extend with additional functionality. And that is where software development becomes actually really interesting. You'll better understand that at the end of this course. So great, we have actually quite a lot of things to cover. So grab a big cup of coffee and let's go. We'll have a quick look on the benefits of Python and why learning Python is actually a pretty good choice compared to other programming languages. So Python is one of the most popular programming languages out there nowadays, besides actually JavaScript, but JavaScript goes more into a different direction, like web development and game development, mobile apps, and building web servers. So, but having Python as the most popular programming language also means that there is a large community out there. So learning nowadays hasn't been easier. So there's a very good online reference and books and tutorials and forums and helpful people out there. So all in all, this makes Python quite easy to learn nowadays. It is actually also quite easy to learn because it has a clear and clean syntax. So does that mean that it's only for beginners? No, by far not. It's very, very powerful, but still a perfect fit for programmers because it has a clear and clean syntax. So it's easy to understand what code does, and thus it's also easy to learn. So for example, if we just compare a printing something to the console, which we'll also do in an upcoming video, here on the right-hand side, this is how it looks like in Python. You're just telling print hello world. Whereas doing that in C++ has a lot more, there's a lot more to it. So for example, you have, these curly braces in here, you have semicolons, you need to call specific things just to print something to the console and so on. So there is actually quite a lot of visual distraction to it, whereas in Python, you simply do print hello world. Now that doesn't mean that C++ is a bad language. It's just different concepts and it definitely has its role. But when you start learning or when you want to learn Python programming, it's actually pretty good choice to just start with Python because it's very clear to read and to write. And all in all, that makes it quite a clean language. So when you're creating well-structured code, you can pretty much almost read that as plain instructions in English what exactly to do. So that makes it pretty easy to read code, which is quite nice. Python is also very versatile. So Python is used in web development, in game development, in software development. You can use it for automating various tasks. It's heavily used in data science, in machine learning and AI, and also in visual effects, which is probably the reason why you're here. So learning Python, that means learning Python can actually open you some interesting doors for the future, not only in the visual effects industry. But Python is also, as you probably know, it is integrated in many visual effects applications like Nuke and Houdini, Maya, Blender, and so on and so on. So when learning Python, you are not bound to, apply all these concepts just to Nuke. You can also create some interesting tools in Houdini and Maya and so on, which is quite interesting. Python has a so-called standard library, which we'll have a look at in an upcoming video. The standard library contains many functions that you will be using day in, day out. So these are things that, for example, working with your operating system, you would like to create, for example, some folders and crawl all files or folders in a specific directory. If you would like to compress some files and read and write data using various file types, and you can use the standard library to launch a web browser, write an email, get time zone information. So there is lots and lots of functionality already built into the standard library, which you always have accessible inside Python. So you can actually achieve quite a lot with just using built-in tools, which is quite handy. But there's also another thing in Python, which is called PyPy, the Python package index, which is pretty much a website. So it's a community where people can share some code. And there are thousands and thousands and thousands of packages out there that implement functionality that is not available in the standard library. So whenever you are in the need of using some functionality that is not contained in the standard library, have a look at PyPy, and chances are pretty high that there is a package out there that contains this functionality. Now, finally, I would like to talk about two technical things that I'd like to mention that are eventually not too obvious for you in the beginning, but they play actually a big role when developing software. So Python is a high-level programming language. That means Python code is independent of the type of the machine they're running on. In other words, Python code is platform independent. So that means you can write your code once and then give it to other people that run on totally different operating systems, and they can still execute the code. Now, this is not the case with other programming languages, for example, C++. In C++, you would need to create your code and then compile it on the machine or on the operating system where you would like to run it on. That's not the case in Python. You can simply give that code to other people that run on totally different operating systems, and they can still run the code, which is quite nice. Python is also an interpreted language, so there is no compiling time required. You can simply write your code and execute it. Whereas, for example, in C++, you always need to wait a few seconds or up to a few minutes, depending on the scale of your software project, before you can actually run your application. So when you're running on large software developments, you definitely see some downtime that you always need to wait some time for having your code compiled. Whereas in Python, you don't really have that concept. You simply run that code. That also has some little bit of disadvantages. It runs a little bit slower compared to C++. But all in all, we're using Python for different things. So speed is not the biggest advantage in Python, but we're just talking about milliseconds in here. So there is definitely a good spot for C++ and Python. Both programming languages have their advantages and disadvantages. They're just used in different fields and for different purposes. So in the beginning, I would definitely stick to Python just because it's very clear and clean, and you can develop things very, very fast. In this lesson, we'll have a very quick overview of what you can actually do with Python inside Nuke and how users can interact with tools. Now, if you already have some Python knowledge, you can actually skip this lesson, but for those who don't know anything about Python at all, it might be helpful to get a better understanding and a better sense about all the different scenarios that you can help yourself with writing some Python code. So what can you actually do with Python inside Nuke? Well, obviously you can automate any repetitive tasks. So you can automate small things, but also large things. And interestingly enough, it's oftentimes the small things that really make a big impact. We'll see that later. So it can be a small tool, but also large tools where you simply automate certain things that you do day in, day out. You can also automate common pipeline tasks to reduce errors on user side. So for example, when it comes to loading and saving and creating shot structures and batch updating multiple working files. So these are pretty good candidates where automating makes a lot of sense, and users don't really need to, create folders and folder structures themselves, because it can be error prone to do that multiple times. And we've been there, everybody has been there. When doing that manually, you do some typo and then you screw things up. What you can also do is change Nuke's user interface and add custom menus and commands and assign shortcuts to them, and we'll do that also later. But you can also override built-in functionality to your needs. So we'll have a look at how this works later. You can also add some knob defaults to reduce time to set up some nodes. So for example, every time you create, let's say, a blur node, you can always set it up so that it always blurs just the alpha channel. Just one example. You can also do some batch creating and manipulating nodes. For example, automatically creating slab comps or doing some sequence-based compositing. And this can really speed up creating comps, especially when you're dealing with hundreds and hundreds of shots. Now, what is also really good for Python is publishing renders or doing any or rendering any other data and handing them over, and to automatically pushing the data that an artist has created, pushing it to other people. So this can also be pretty much automated. You can also communicate with third-party software. So for example, write something to the database or read something to the database, send something to an external render application, and so on. So ideally, the user just needs to press one button and many things happen automated in the background without the need to do anything manually anymore. This is how I also usually describe to other non-technical people what a pipeline TD and a software developer in visual effects does. Now you can also run tasks automated in the background. So for example, doing some multi-threaded archiving or multi-threaded rendering. So this is where it really becomes fun. Now there are certain ways how users can interact with tools, which we also want to discuss quickly here. So a user can execute any functionality in the menu bar. And that's also what we'll be doing in this course later. We'll add some custom menus and add some custom commands to it so that a user can click these commands. Then they execute some important functionality for us. We can also create some graphical user interface, and the user can then interact with these. And oftentimes, these graphical user interfaces, they often get launched via a command also in the menu bar or via a shortcut. And that's also what we'll be doing in the upcoming lessons, but a little bit later. Now you can also execute any functionality via the API, which is the application programming interface. But this is more for technical people. But that's also what we'll be doing throughout this course, because developing and testing via an API can be way faster than clicking any buttons in a graphical user interface. We'll see later how that works. Now, one last thing, what you can do is users can also interact with some functionality using a command line interface. This is something we won't cover in this course, because I think, in the beginning, you don't really need this information and we just rather want to concentrate on some more fun things. So for example, creating some custom menus and adding some custom commands to it, and also, creating some graphical user interfaces. So I think this is way more fun than creating command line interfaces. But these are also very important to execute some tools. So these are all the potential ways of how users can interact with any tool. In this lesson, we'll have a look at Nuke script editor, how to access it, what components it has, and how to write and execute code inside it. Now, as I expect you're familiar with Nuke, we'll actually keep programming inside Nuke script editor for quite some time. Later in week 5, we'll switch over to an external editor in which we'll write our code. But for now, let's just stay in a known environment. So Nuke script editor is a good choice for creating and executing a few lines of code and quickly trying out different things. One of the great features is that it lets you execute a selection of code, which is actually a really handy feature. We'll see that in a minute. So let's first have a look at how we can access Nuke script editor. So if you have a look here, we'll find some boxes in here. These are called pane menus. You can also find them in here and in here. So if I scroll down, I find the menu windows, and in here I find the script editor. Let me enlarge this section a little bit. So this is how the script editor works, which we'll see in a minute. For now, let's just create a programming layout that we'll be using throughout this course. So if I click into properties again and click and drag it to the right, I have now moved the properties bin to the right, and I can enlarge the script editor section here so that I have enough room for creating my code. Let's enlarge this a little bit so that we see all the knobs. So this is fine. So what I can now do is save this as a workspace. So if I go here to workspace, save workspace, and let's call this, for example, custom, hit OK. Yeah, I already have a custom layout. That's okay. Let's replace it. It has been replaced. Okay. So what we can now do is we can also save this as our startup layout, because I don't want to, always launch Nuke and then switch to the correct workspace. I want to have this as my custom startup workspace. So let's go to, let's hover over the node graph and press or hold Shift and press S to get to the preferences of Nuke. And if I go here to startup, I can set this as my custom layout, which I have already done because this is what I always use inside Nuke. So let's hit OK. So whenever I close Nuke and relaunch it, I will start with this layout again, which is always my preferred choice. So this is how we got access to the script editor and saved it to our layout. Let's now have a look at all the components of the script editor. So here at the top, you will find some buttons. Then this section is the output section. This is where you see all the result of executing your code. And in this bottom section, this is where you write your code. So you can write some text in here, right? So I don't really use these buttons too often, but let's discuss this, what you can do in here. So when you execute some code, if you want to, when you execute some code, it gets saved into a history. If you want to go back to the previous code that you've written, you can use this button to go to the previous script, obviously. With this one, you can go to the next script. And with this button, you can clear your history. I don't really use these very often, but they are there, so which is quite good. What you can do with this button is you can source a script. So you can, this will load a Python file and into the input section, and it will automatically execute it, which is sometimes quite handy. I also don't really use that very often. With this button, you can load an external Python file into the script editor without executing it. So you can execute it manually if you want. If you've written some code, you can also export it directly from the script editor, which is what you can do with this button. And this button is really important. This is how you can run your code. So when you program something, which we'll see in a minute, when you write something and you want to execute it, you hit this button. But a faster way of always navigating manually to this small button in here is actually using the hotkey, which you can also see in the tooltip, Command or Control if you're on Linux or Windows, and then pressing return. If you click this button, you can enlarge the input section. And if you click this button, you can enlarge the output section. And with this button here, you get back to the default layout, which is seeing the output section and the input section. And with this one, we can also just see that in a minute. With this one, we can clear the output window. So what we see here. Before we write some code, let's first have a look at the script editor settings, because there are also some settings. So if we hover again back to over the node graph and press or hold Shift and press S and go here to script editor, we see Nuke offers a few different settings for the script editor. In here you can change the font, which I don't recommend to do that. I would stick with Korea, because Korea is some special font where every character has the same width. So for example, the width of the character I has the same width of as the width of the character M. So I and M, for example, I as an example as a, rather short character compared to M, which is they have the same length. So overall, I would just stick with Korea for now, because with that, you will simply ensure you have the correct format. And here you can increase or decrease the font size. For this course, let's stick with a little bit larger font size, for example, 18. I wouldn't mess with this indentation. So we'll later see what indentation means in Python, but here you can set up how many spaces you would like to have for indentation. Python always use 4 spaces with indentation. I'm not quite sure why you can update or edit this here. Don't do that. Stick with 4. This is Python's default. Save and restore script editor history. Keeping this on is quite handy, because when you quit Nuke and when you then relaunch it, what you have previously written will get restored in the script editor, which is quite handy. Echo Python commands to output window. Now this is quite interesting. Let me show you how that works. If I click on OK, and if I, for example, create a blur node, so hovering over the node graph and pressing B, right? Then you get a blur node, and then you can also see what Nuke executes under the hood. So we'll later see what this actually does, but you can see here, this is the actual Python command that got executed. Now, if you have some Maya background, then you will probably know that there is some functionality called echo all commands, which does basically the same. It outputs everything that it executes under the hood. So for example, if you, if you're creating a sphere or a cube or a camera or something, then you can always see, if you have turned this on in Maya, you can always see the underlying command that gets executed. This is pretty much the same here in Nuke, but in Nuke this is very limited. So you will just see that very sparingly, because not everything has a Python command under the hood. But if you turn this on, for some actions, you will see what Nuke actually executes under the hood. So if I go back to my history, this is also some interesting behavior that you can either turn on or off. So clear the output window on successful script execution. Let me quickly show you how that works. So at the moment, this is turned off, right? So if I click OK, and if I execute now some code, we'll later see, or in the next couple of lessons, we'll execute some actual Python command. But let's just do that very simple for now. So let's just use a simple calculator, if you will. If I enter 1 + 1 and execute the code, so again, this button, or holding Command or Control and enter, you see that this code is still existent in here. But if I now go back and say clear the output window on successful script execution and click OK, then if I execute this code, it is gone. So I can now bring it back with the history. But I think this is quite annoying whenever you execute something that it's gone, right? What you can do, if I bring this back, what I can always do is I can select my my code that I want to execute and then hit Command or Control and enter, and then it stays in here. And I'm actually pretty much accustomed to selecting some code and execute it, which you will see me doing all the time in this course. So, but still, I don't really want to have this behavior that whenever I execute something that the code is gone. I don't want that. And you know, I can always bring it back by using this button, but I always keep this checkbox turned off. So if I click on OK, if I now execute this code, so Command and Control and enter, Command or Control and enter, and I can now see the result. So as previously mentioned, you can clear the output history with output window rather with this button, so that the output is now gone. If I execute this again, I use the hotkey, which I would also recommend for you doing that. So this is, if you hover over here, you see Command or Control. I am on Mac, so I always have Command in here, but it's Command and backspace. So if I hold Command or then Control and backspace, then what I've executed previously, that's the output is gone in here. And similar for the input window, what I can do is hold Control and Command, and might go this back here. So Control and Command, and the output window is gone, right? So this is it pretty much. One last thing that I would like to show you. So you have seen we can execute some code in here, some very simple code. So if I, for example, want to execute another code, or rather print another result, if I, for example, use then 4 + 4, and if I have 1 + 1, if I now execute this, let's do Command and enter, you see the result, there's nothing printed. So why is that? So Nuke has the behavior of just returning one value. In here we have two values, so if I want to get this value, I select it and I hold Command or Control, Control or Command and enter, then I can see the result in here, and I can also get the output of this one here, which is now 8. But if I select both and do Control or Command and enter, I see there's no result. So Nuke can actually just print one result if you're not explicitly printing it. In the next lesson, we'll have a look at print, but for now, to get both outputs in here, we can use print and then in round brackets. And to go to the very end of the line, I hold Command or Control and the right arrow key and close the round bracket. So I now have print 1 plus 1, which is 2. And I do the same, print 4 plus 4, and execute this section. And I get 8. But now as I'm explicitly telling the script editor to print the result, I can now execute or select both and execute them. And you see here, I get both results printed. So always something to keep in mind. You can execute one or several lines of code, but only get one result in the output window. The code gets actually executed, but you don't see the result in here if you want to execute several things. If you need some results printed, you need to explicitly call print and then what you want to get executed. So that's it for this lesson. So we'll had a look at how we can access the script editor, had a look at the all the components it has, and how we can execute code, and also how we can set up the script editor in the settings. In this lesson, we'll have a look at a fundamental technique in programming, which is printing something to the output. Now, when learning a new programming language, it has become quite the standard to first learn how to print a hello world to the console. So let's see how that works in Python. So for that, we use a keyword called print. And then in round brackets, we tell the Python interpreter what to print. Now we'll have a look at variable types in one of the next lessons. Let's first just use double quotes and then hello world. Let's select it and execute it. And you see here in the output, hello world. Pretty simple. Now in Python 2, you don't really need round brackets, so you could do something like that and it works. But in Python 3, this does not work. This is one of the differences between Python 2 and Python 3, is when using print, you need round brackets, because otherwise you'll get a syntax error. And you also get a hint that you might have missed the parentheses. So it's add the round brackets again and execute it, and you see hello world gets printed. Now overall, there's not too much functionality to print, although it's pretty important. There's nothing much further you can do with it, but I just wanted to show you a few things that you can do with print. So for example, you can multiply a print. Let's see how that works. So let's, for example, multiply hello world by 3. What does that output? Well, the result is just printing hello world 3 times. Does not really look very useful, but what you can do, sometimes you just need a divider. For example, print dash, but print it 50 times. And then you get a nice little dash in here. Sometimes you will need that. Now you can also concatenate several outputs. So let's use another print. And let's write hello and then plus there. Select it and execute it, and you see hello there gets printed to the output. Now at the moment they're just put together. So let's use a white space here or here. Select it and execute, and you get hello there. Now, one of the nice things about printing is that you can use, or you can print several things in a row. So let's use another print. And let's use hello. And now instead of using a plus, we can also use a comma. I am a text. So we print all of these things one by one, and what we get is we get this text in here, and the the elements in here, they are already separated by a white space, which is quite handy. So when printing, you can always specify several elements to print. We'll have a look at functions later, but what we're using here are arguments. So print takes several arguments. Now, when printing a long line, we usually want to avoid, having hundreds and hundreds of lines that are, or lines that are several hundred characters long. So what we usually do is we can separate these into several lines. So how that works is we can simply write a long line. So hello, I am a long line, and then a comma, but I still appear in one line. So what we're doing here is we're separating this into several lines, but when we're printing it, it still appears in one line. Quite handy to have this because we always want to have short lines. Now we'll have, as mentioned, we'll have a look at variable types in a future lesson. So what I printed here was always text, but we are not limited to text. So we can, for example, also print numbers. So for example, 1, select it and execute it, and we can print 1. And we can also use that as a calculator. So for example, 1 plus 2, and we get the result 3. So that's it pretty much for the print statement. In the next lesson, we'll also have a look at another very big important detail when it comes to Python 2 and Python 3, which will also involve the print statement. Before we continue with the Python basics, we'll have a quick look at some differences between Python 2 and Python 3, as this is some important detail to know here. So Python 2 is the former Python version which got used in the past, and it is already quite old, and it got deprecated in 2020, and it also receives no more updates. So the last Nuke version that used Python 2 is Nuke 12 from 2021. So it is already 3 major Nuke versions behind the latest version, Nuke 15. And everything from Nuke 13 and above uses Python 3. So you might be wondering if this is still relevant. And the answer is actually yes and no at the same time. It is actually quite good to know that there is an older Python version out there. And in fact, there are many tools and scripts that only exists in Python 2. So knowing some differences is still quite important nowadays, even if Python 2 has been deprecated some years ago. Now, over the time, this Python 2 will become less and less important, but keep in mind that there are still many scripts out there written in Python 2, so knowing some differences between Python 2 and Python 3 is actually quite valuable and important. So why was there a move to Python 3? So Python 2 contained many inconsistencies and technical debt, which has been removed or cleaned up with Python 3, but that also caused some incompatibility with Python 2. We'll see that in a minute, that Python 3 code behaves differently or cannot actually be executed in Python 2. And vice versa, Python 2 code cannot be executed or behaves differently when executing it in a Python 3 environment, which we'll see in a minute. So we'll see that in a minute how several details change within Python 2 and Python 3. And you might be wondering, should I now learn Python 2 or Python 3? And the answer is clearly, definitely a Python 3. So you should not really use Python 2, or actually you should not learn Python 2 anymore. Sometimes you will actually, if you're working in some legacy scripts, you will still need to maintain Python 2. But you should definitely work towards Python 3 and only use or apply that one. So let's have a look at some differences between Python 2 and Python 3. So here on the left, I have a Python 2 environment because I'm using Nuke 12. And here on the right, I'm using Nuke 13, so Python 3. Now, there are several differences between Python 2 and Python 3. Overall, Python 3 is not really a new programming language, but there are some differences. So in the previous lesson, we've already seen that using print, we can output to something to the output window. And in Python 2, you actually didn't need to use round brackets, which we've seen in the previous lesson. So we can, for example, do something like this, just print hello without round brackets. So if I execute this, we get the output. But if I do the very same in Python 3, we get a syntax error. And we also get a hint that we might have missed the parentheses. So in Python 3, we always need the parentheses. Now, interestingly, in Python 2, you can use parentheses, which obviously means that I would simply stick to always using parentheses, no matter if you're in a Python 2 or Python 3 environment. But just keep in mind, in Python 3, you always need round brackets. Now, there are several other important differences between Python 2 and Python 3. So for example, with the move to Python 3, some modules have been moved to a different location, or the name itself has been cleaned up. We will have a look at modules in one of the next lessons. But one thing which I can show you now is if I do, for example, from Q, import Q. I can do that in Python 2, but if I execute the very same in Python 3, I get a module not found error. So why is that? Well, in Python 3, this Q module, as it's a module, the convention is actually to use lowercase. So this has been simply renamed, right? So if I execute this, I can now, I have now Q imported, but here in Python 2, I need a capital Q, and here I need a lowercase q. So this is much more consistent because it's a module, and by definition, a module should be lowercase. So this is one example where some inconsistencies have been removed in Python 3. Another difference between Python 2 and Python 3 is that you can sometimes get different behavior. So let's have a look at how that works, or how that looks like. Is if you are dividing some integer values in Python, so for example 3 divided by 2, you don't get 1.5. So you get the just the integer value, so the 0.5 gets cut off. Whereas if you're doing the same in Python 3, let's copy that one. If you're doing the same one in Python 3, you get the result that you would rather expect. So you get 1.5. 3 divided by 2 is 1.5. So this is actually quite interesting behavior, and it can cause quite some unforeseen bugs, because if you think about it, your script is now behaving differently. So if you, for example, if you're setting up some knobs or something, you don't get an error, which you got, for example, when you did something like that. So your code in this example, it did not run at all. or just up to the point where it had to import from queue. But this is now really hard to see because here it doesn't print an error, but it behaves differently. So this is really something to keep in mind if you're going through some legacy script and you're having thousands and thousands of lines of code, then spotting this can sometimes be quite hard. So, but there is some help. There is some automation to port some legacy Python 2 code into Python 3 in an automated way. But at the end of the day, you will always need to manually look at the translation from Python 2 and Python 3 and verify yourself if what the automation has done is actually correct. And let's quickly go to websites for that. So there is an automation called Futurize, which lets you convert Python 2 code to Python 3. Here on this website, you'll see some different behaviors of Python 2 and Python 3, which we've also discussed. And there is some automation. I don't want to go into detail about this, but if you've installed this, you can run Futurize on a module, so a single Python file, or also on a Python package, which is a folder that contains several modules, and you can automatically run Futurize on it to convert your legacy Python 2 code to Python 3 code. But at the end of the day, you should always verify that the automation here worked as expected. So always keep that in mind. So it is actually quite important to know about all these differences in here, right? So these are just some very common things. So in some scripts, you will see some print statements and changing the print statement in here and just adding round brackets. That's actually quite easy. Also, knowing that there is some module name change, some modules got moved to other locations. That's also simple. This is a little bit more tricky because it does not fail, as mentioned, but it creates different behavior, which is important to know. And here I've also some more valuable URL, which you can have a look at if you are in the need to, translate old Python 2 to Python 3 code. But I won't go into detail about this because this is a totally different section in here, which we don't want to cover here. So we want to actually cover how to write clean and modern Python code in Nuke, right? So yeah, this is it for this lesson. We'll have had a look at the key differences between Python 2 and Python 3. So as this is now out of the way, we can continue with the Python basics. In this lesson, we'll learn how to add single line and multi-line comments to our code and what else we can do with comments, and also some best practices when it comes to commenting our code. Now, everything on the right-hand side of the hash character will be skipped when executing any code. And that means that we can use this for adding comments into our code. So let's see how that works. So if I, for example, print 1 and 2, then we can add a comment in between by starting a hash character. And then, for example, writing this is a single line comment. And when we execute this, we get 1 and 2. But this line in here, as it starts with a hash character, it gets ignored by the Python interpreter, and this becomes a comment then. We can also add a comment at the end of the line. So by definition, it's pretty common to use 2 white spaces, and then we can add our comment. So if we execute this, we also get 1 and 2, and this one here, as it's a comment, it gets ignored. Now we can also add multi-line comments, and we do that by using 3 quotes. So we surround or wrap our comment between 3 quotes. So for example, this is a multi-line comment over several lines. And if we execute this, then we also get just 1 and 2, and this multi-line comment gets ignored. Now, when it comes to writing comments, there are some best practices to keep in mind, which we can have a look right now. So you should use comments sparingly, because too many comments are pretty much white noise. And you can often see this by programmers who just started programming, that they tend to comment every line, and you don't really need that because you're unnecessarily bloating up your code. And you should only use comments when you really feel the need that you need to explain something to either yourself or the code reader. You should also explain the why and not the how, because if you feel the need to explain the how, then this is pretty much obviously a signal that the code is not as readable as it could be and needs some updates. Having no comment is actually better than having a bad comment. So you shouldn't be afraid if your code is not pretty much commented. That's often case not really the problem. But if you're having some really bad comments that don't really tell you anything, you are really unnecessarily bloating up your code, which you should avoid at all times. As you're writing some comments to either yourself or to a reader, you should really stick to writing full sentences and also beginning with a capital letter and also ending with a full stop, because you're telling some people or yourself some valuable information. What you can also do with comments is you can temporarily disable code, which we'll see in a second. But it's also really important that when you're done with your work, you should really either remove the code or uncomment it, so that you don't keep commented code in or commented lines in your code. So let's quickly have a look. For the Python interpreter, it does not really make any difference if you're, comment, or if you're writing a comment that contains some human readable information, or if it's actually code. So what you can obviously also do is simply add a hash to this line, and that it does not get executed anymore here. So at the moment, I'm just executing 1. So if I take that back, we see that 2 gets now executed again. So this is some pretty useful thing that you can sometimes do to temporarily disable some code if you need to check something. Now, comments can easily get overlooked, and that's also the case because, so if we go back in here in Nuke ScriptEditor, the comment is green, but in many other programs and IDEs, which we'll also see later, comments tend to be marked by default in a light gray. So they are not that obvious and they can easily get overlooked. So that also means that if you update your code, chances are high that you actually forgetting to update also a comment, which can be a big problem because then the code itself and a comment, they tend to drift apart. So you should always have a look, and if you're updating code, you should always have a look that you also update your code, your comment as well. We'll also see in a later lesson when we switch to PyCharm how we can update the comment color. So these are some best practices to keep in mind when writing some comments. In this lesson, we'll learn about some basic variable types that you will be using day in, day out, and also some common things that you often do with these variable types. So we'll have a look at strings, integers, floats, and Boolean values. Now, a variable are simply containers that store values so that you can reuse these values over and over again. And this is actually a fundamental concept in programming that you'll find in all programming languages. So the idea is quite simple. How does that work? you use a variable name and then an equal sign, and then you assign the value, and that's pretty much it. So as mentioned, there are certain variable types, and we'll have a look at these aforementioned types in a minute. But this is how it would actually look for all these variable types. So for example, when storing a string, which is simply text, we use a variable name followed by an equal sign, and then as it's a text, we need to wrap it in quotes. So for example, John. So we create a new variable, call it name, then do an equal sign, and then assign the value John to it. And with that, we can now always refer back to this variable and call this value. Same for all the other types. So for example, storing an integer value, so a full number. So for example, we use age equals 30. And then we can also store floating values. So these are integer numbers, but with a decimal point and then some numbers after the decimal point. So for example, price equals 9.9. And we also have something which is a Boolean. So in a Boolean, you can store a state. So it can be either true or false. Now, there are some conventions that you should be aware of when using variables. You should always use a descriptive name. So for example, name equals John and the age equals 30, because with the name of this variable, you should make it clear what this value actually stores. So for example, here it's storing an age or a price. So you will see me doing, using some very weak variable types. For example, a equals 3 or b equals hello, but this is just for demonstration purposes. So to keep things short, but in a real project, in a real software environment, you should not really use the variable names A, B, C, or some very undescriptive name. You should always use descriptive names, right? Variable names should only contain lowercase characters, numbers and underscores. And I would be a little bit careful with numbers. So in most cases, you should be pretty much fine just using lowercase characters and underscores. And I wouldn't, for example, do something like name 1, name 2, name 3, because at the end of the day, this also goes back to this statement that you should use descriptive names. A variable should pretty much describe what value it stores. You cannot start with a number. So for example, you could not use 1 name or 3 age. That does not work in Python. So you always need to start with a letter or an underscore. That's also fine. You should also not use camel case and no Hungarian notation. So these are some notations that you often find in other programming languages. So for example, camel case, that would be something like this, where you concatenate several other things. So for example, this information string, and then you start with a capital letter to start the new name, or the new element inside this variable. So you shouldn't do that. It should be, for example, string, underscore, and name. But that also brings us to one further thing. You should not use the variable type in the variable name, because we will see that in just a minute, that Python is dynamically typed, and when it's called string underscore name, it is not very guaranteed in Python that it really stores just a string, because variables can always change their type. We'll see that in a minute. So these are some conventions to keep aware of. So let's now have a look at how we can create some variable types. So for example, I do, as already seen here, I create a variable name. And as mentioned previously, this is just for demonstration purposes. This is a weak name because it does not really, it contains the variable type, which you shouldn't do. And it's also not very descriptive, but this is just for demonstration purposes. We'll have a look at more strong names in the following tutorial. So, but let's just keep this simple for now. So let's do my string. And then, for example, I am a text, right? So we have now stored this value to this variable, and now we can reuse this variable. So for example, we can print my string. And you see the result is I am a text. So let's, for example, also create another string equals I am a text 2. And also print this one. So another string. So we have here now this first variable, and here we are printing the other one. And what we can now do is we can also combine this. So for example, we can do print my string and then plus and another string. So I am a text, I am a text 2. Let's, for example, concatenate these with a white space. So for example, we can use another plus in here, and between these two pluses, we use another white space. It makes it a little bit more readable. So I'm a text 2. And what we can also do, we can store this value in another variable and call that. Right? So for example, we can create another variable called combined equals, we don't need the round brackets in here. So we create a new variable, and in this variable, we reference the value of my string, which is I'm a text, then a white space, and then the value of another string. So if I do that and print combined, then I get exactly what I expect. I am a text and I am a text 2. So you can also combine variables, which is a pretty interesting technique that you will also be using day in, day out. Now, as previously seen with comments, we can write multi-line text. So for example, multi-line equals, and then we use 3 double quotes. And then, for example, hello, I am a multi-line text over several lines. So if I assign this, I selected my value and my variable and hit or pressed Command or Control and Enter. Then I assigned this to this value here to this variable. So I can now print multi-line. And I get the result. Now what you can also do is when you have some very long lines, but you still want to wrap these in or have these in one single line, what you can do is, for example, you can, let's just call this another, create a very long text over several lines. Hello, I am a text over several lines, but as I'm now not using triple quotes, I just use a round bracket, and in this round bracket I put several strings. If I now print another, then this is in one line because I'm not using triple quotes. Now, every variable type has some functionality that we can also inspect all the time, which is quite handy. So let me show you how that works. So there is a built-in type, built-in functionality called dir, D-I-R. So what we can do is we can print all the functionality that, for example, a string has. And the short form for having a string is str. This is the variable type. So if I execute this, you see all the functionality that a string, a text has, which is quite handy because every time you create a variable, you have certain functionality directly to it. So for example, you could for example, create an upper version. And what you can also do is you can print some help on this specific function here. So how that works is you do again print, and then there's another built-in functionality called help, which is quite handy. So for example, help, and then the functionality that we want to call, and this upper functionality, this is in the string. And how you do that is you use string, so str, which is the type, and then upper. So print, then the help, and then in round brackets, the variable type, and then the function name. So if I do that, if I execute that, we get the help, what this function does. And what does it do? It returns a copy of the string converted to uppercase. So let's see that in action. So for example, print, and then we want to call the upper function on a string. So for example, hello, and then we call upper. Now, as it's a function, and we'll later have a look at functions, what you need to do is you need to add round brackets as you're calling a function. And when we're executing that, we get hello, but printed everything in uppercase. And you can pretty much, go through all of the functionality in here and play around a little bit and see what it actually does. So for example, there's a counterpart, there's also a called lower, and certain other things that we will cover some of these things in this course. There are some functionality that you will definitely use day in, day out. So for example, also count. Let me quickly show you how that works. So for example, or let's first print the help of count. So let's see what does it do. So it returns the number of non-overlapping occurrences of the substring. So let's, for example, see how that works. So the count of the substring, so for example, how many times L appears in this word hello. So for example, let's call this hello.count and then L. And you see the letter L occurs twice in hello. So using dir and help, you can pretty much help yourself directly in the script editor to find out what functionality a certain variable type contains. But of course, you can always do some web search and see what functionality is available. But this is a pretty simple and pretty effective way of quickly researching what is available on a certain type, right? So that's it pretty much for a string. Let's have a look at integer values. So integer values, as seen here, they store full numbers. So for example, if we use a equals 1, and then we can print a, we get the value of 1 as a result. So we can also assign another variable. B is, for example, 2. And then, as we've seen before here, we can create another variable and, combine these two things. Now with integers, this does a mathematical calculation. So for example, if we do c equals a plus b, and then we print c, then we obviously, oops, sorry, I have not executed that one. So if we now print c, then we see the result is 3, as we're dealing with numbers and they are pretty much, added up. So we can also do some dir on an int. So this is how the variable type is called, int. So you see, int also has a lot of functionality built right into it. And I haven't shown this, but you can call dir on an int, but you can also call it on a value, and Python will then figure out the type that you're inserting into this dir function. So also what we could have done in here, dir string, we could also do the dir directly on a value that is a string type. That is also the same behavior. So the Python interpreter will figure that out for you. Let's actually keep this just for reference. So here's all the functionality for an integer value. Next, we'll have floating values. So as seen here, we can create a variable type and then assign a floating value, so a number with a decimal point and some numbers after this decimal point to it. So let's, for example, do my float equals 1.1, and also another float equals, let's say, 2.2. And for example, the sum, that's actually not a good name. So if I select this one and execute it, you see that the word sum is actually a built-in functionality. So you shouldn't really assign a value to this specific name, because you're then overriding some built-in name. You shouldn't really do that. So let's, for example, call this float sum. Again, these are very weak names actually, but I'm just using them for demonstration purposes to make things very obvious. You shouldn't really use a variable type called myFloat or another float. This is not how you should really name things. You should have really clear and precise names, and you shouldn't include the variable type, because we'll see that in a minute, that it is not very ensured that this variable type is actually contained, or rather that this value assigned to this variable is actually this specific type. We'll see that in a minute. So for example, here now use float sum and say this is, I'm just copy pasting it now. So float sum equals my float plus another float. If I execute that, I just need to execute everything. If I now print float sum, you see we get the result in here, right? Now, interestingly, there is some rounding error in here. And I won't go too much into detail about this, but there are certain other mechanisms to ensure that you don't get any rounding numbers in here, right? So if you see here 1.1 plus 3.3, you would actually expect exactly 2.2, you would actually expect exactly 3.3, but this is not the case. I would just leave this for now because it's not important right now. Just keep in mind that these rounding things, they can occur in Python. but we won't deal with this right now. So these are functionalities, or these are the floating points. Lastly, would like to have a look at Boolean values. So as seen here, with Boolean, you can store two different types, true and false. So let's, for example, use a equals true. And then we can print a, and the value is true. And we can say b equals false. So they are capitalized, true and false. So b is false, and print b, and this is false now. Now these Boolean values are quite important because we'll see that in an upcoming lesson when we're dealing with if-else statements. So if control structures, you will always then use Boolean values to execute code only when some condition occurs, or if it doesn't occur, depending on your logic. But what we can do now with these true and false, we can check some things. So for example, let's see if, for example, the number 9 is larger than the number 10. So if I execute this, we get a false because the Python interpreter now checked, is 9 larger than 10, which is not the case. So it returned a false state. So we can also obviously do the same and make a true. 9 is smaller than 10. If I execute that, then we get a true. There's also another comparison operator, which is the equal sign. And pay attention to, let me quickly do some empty lines in here so that we're not dealing too much on the border in here. So there are two equal signs. This is a little bit different to one equal sign, obviously. With one equal sign, you assign a value. So for example, this one here to this variable. But with two equal signs, you're comparing things. So here you're asking if 9 is equal to 10. Which obviously is false. One last operator that we can use is if 9 is not equal to 10. And with that, we use this exclamation mark and an equal sign. And if I execute this, then we get a true because 9 is not equal to 10. So these are some common variable types, and we'll further explore them when dealing with if-else statements in an upcoming lesson. What I haven't told you so far is that you can obviously mix some variable types. So for example, you could, let's assign another variable. Again, I cannot emphasize this enough. This is not a good variable name. As mentioned in here, you should always use descriptive names. But just to keep this simple, let's just stick with some very simple variable names for now. So what we can do, for example, is create the sum of an integer and a floating value. So for example, a equals 1 and b equals, for example, 2.2. And then we can print a plus b, and we get 3.2, right? So you can actually mix these things. What you can't do is, let me create another variable type, another variable c, and for example, is store some text to it, right? So if I now print, for example, a plus c, I would be combining an integer with a string, right? So if I execute this, I get an error, a type error, unsupported operand. So the Python interpreter cannot combine an integer, which is the a, which is the value 1, with a string, because we're using C, which is text. So we cannot concatenate one and a text. What we can do is we can cast this or this one here to a string so that it's not handled as an integer, but it is like, you know, wrapping a 1 with quotes, which makes this effectively a text. So how we can cast this is we're using the variable type, so str as seen previously, and then we wrap our variable in round brackets. So if I execute this, we can actually concatenate this. So one text, we can do that. Now we can also cast to other types. So for example, we can cast an integer to a floating value. So for example, using now float and then an integer value. We can also do that. Now we can always get the actual type of a variable by using the built-in functionality type. So let's see how that works. So we can use, you can print, then use type, which is a built-in class. And then in round brackets, we tell Python what type to print. So for example, get me the type of the value hello, which is obviously a string as we've seen before. You can also do the same for example, for an integer, right? You're getting an integer value. Same for floating and for Boolean values. Now I've mentioned that before, but Python is a dynamically typed programming language. What that means is you can change actually the type of a variable on runtime. So let's see how that works in action. So let's use another variable called a and assign a string hello to it and print a, which obviously prints hello to the output window. We have seen that quite a lot of times before now. What we can now do, and this is actually quite interesting, you cannot do that in all other programming languages. But what you can do now is you can assign another value to it, and it can also be a totally different type. So for example, we now call a and assign an integer value to it. And if I now print this value, let's also print the first assignment. So first we get hello, and then we assign the value 1 to a. So we are effectively changing the type of the variable. And we can continue doing so. So for example, a equals true, and we can then print a. And you see in here, we go from a string to an integer value to a Boolean value. So this is something you can do with Python. And this has actually some advantages and disadvantages. It makes you more flexible because you can change, obviously, types on runtime. But that also means that potentially a variable is not ensured to have the correct value or the correct variable type. So let's, for example, say we're creating some functionality that depends, for example, on a string, but we're passing in an integer or a true. This could either break our code or it could effectively change the behavior of the code. So this is something to be aware of. You can actually not do these things in other strongly typed languages like C++. So when you declare a variable and say it's a string and add some text to it, then you cannot change the variable type on runtime. So you couldn't do this in C++, for example. Just something to keep in mind. What you also sometimes need is using some constant values. So some values that don't change over time. Python does by default not have such a concept, but you can, we will see that in an upcoming lesson, you can add some, or you can create some constant variables that, you know, don't change their type by default, but there's a little bit more work to it, how to get there. So how Python does that, there is some convention. So if you are having some variable type and it's all uppercase, so for example, let's say path equals, and then, you know, the absolute path to some file, for example. So for example, some configuration. Let's just do some dummy path, path to config, for example, some JSON file. Then this value in here should not change. But in Python, as this concept of a constant does not exist by default. So what you could do, let me quickly, just for demonstration purposes, print this path. And obviously what you can do is change this to something else. And then print this path again. And you see you're changing what should actually not be changed. So this is a convention. If you're seeing a variable type that is all uppercase, it's supposed to be a constant that should not change over the time. And we'll later see some concepts of how you can actually achieve that. But by default, every variable can be changed on runtime in Python. So this is some basic overview, some short overview of some simple variable types. So we had a look at strings, integers, floats, and booleans. And these are the common simple variable types that you will really use day in, day out on pretty much all the code you write all the time. In this lesson, we'll learn various ways of printing a string with some variables to resolve. So let's say I have a variable called name equals James. And now we want to print a string, hello, my name is, and then we want to use the value that is stored in name. So in this example, James. So let's say print hello, my name is. And how do we do that now? We can obviously not use this. So let's execute this to show how that would look like. So this would effectively return hello, my name is name, because at this stage, this is simply just wrapped in text, right? But we want to have this value in here. So how that works is we replace this name here with curly braces. And then we use some built-in functionality, which is called format. And we tell the Python interpreter to translate this value in here, the curly braces, with, or to substitute this curly braces with the value of this variable. So for example, in this example, it would be name. So if I print this, I get hello, my name is James. And this is some really effective concept that you will definitely use day in, day out to create a string which contains some values of a variable. Now, there are various ways to write strings with some variables to resolve, which we'll have a look at now. So let's add actually a few more variables in another example. So for example, use, let's now say Tom, age is, for example, 30, and country is, for example, France. I can spell it correctly, France. So let's now print a string. Hi, my name is, and then the name, in this example, Tom. I am then the age, in this example 30, and I am from this country, France. So again, we could use print, hi, my name is, and then again use curly braces. We'll substitute it with the value of name. I am, and then the age, I am 30, and I am from, and then the country. So I've seen before we can use format, and then we need to pay attention to use the correct order. So in here we would like to insert the name, followed by the age, and then the country. Oops, where is my fault? For name equals Tom. Syntax error. Oh, I forgot an equal sign. Hello, my name is Tom. So whenever you are assigning a new variable, you always need to use the variable name followed by an equal sign and then the value. Let's just print this line to make it more obvious. So, hi, my name is Tom. That is this value. I am 30. That is the value of age. And I am from France. That is the country. So we've seen that before, using curly braces and then using format. Now, when you're printing a long string and having lots and lots of variables in here, it can get quite easy to mix up these orders. So what you can also do is, let me just copy this one. You can insert some indices. So we're using, and it always starts with 0. So my name is the first, 0 is the first variable that we're using here, I am, and then using the second variable, and I am from the third variable, which is index 2. So if I execute this, I get the very same result in here. Hi, my name is Tom, I am 30, and I am from France. Now, when using indices, you can, in your string, you can reuse the variables that you insert in here. So let's, for example, say my name is really, and then you are referencing the name again, which is the first index. So although we're using 4 curly braces in here, 1, 2, 3, 4, we can actually get along with just using 3 variables, because in here we're using the first variable again. So here you see again, my name is really Tom, because we're referencing with 0, we're referencing the first variable again. So this is how you can use indices. Just remove that. Let's just keep this simple for now. What you can also do is when you're having some long strings and you don't want to pay attention to the exact order, what you can do is, let me copy this one. We can replace the indices with actual placeholders. So for example, I use name in here, and I use age, and in here I use country. And what we can now do is we can format and say, for example, the name that I reference in here is the value name. Let's increase this a little bit, and age equals age, and country equals country. And I'm exactly printing the same value again. So you don't really need to specify this exact variable name in here. What you could also do is doing something like this. And then you say the n in the string will be substituted by the name. the A in this string, because it's in curly braces, will be substituted with H, and what we where we use C in here, this will become the value of country. And I'm left here again with this same sentence. So, hi, my name is Tom, I am 30 and I'm from France. Now, since Python 3, there is some new concept, which is called an f-string. And this is some really important and new fancy feature. Let's see how that works. We can prepend an f before we use the double quotes. And with that, we're telling the Python interpreter this is an f string. So what we can do is we can again use this the sentence. So let me simply copy that over. Oh, sorry. So hi, my name is, and now we actually need to use these full variable names. So we use name, age, and country. And with f-strings, we don't need this dot format and then specifying the variables anymore. So we have now created a new variable called text, and we assigned the f-string to it. So we can now print the text. And we see we are left here with the very same value. Hi, my name is Tom, I'm 30 and I'm from France. So these are all the various ways of how you can actually create a string that has some variables that get resolved inside the string. So we can simply, to recap, we can simply use curly braces in here and use format, and then we need to use the exact order that we need to substitute these with here. So for example, if I use name in here, the very first occurrence will be substituted with the value of name, which is Tom in this example. We can also use some indices and reuse these indices inside the string again, as we've seen. We can also use some placeholders in here and say n will be substituted with the value of name and a with h and so on. And since Python 3, this is only working in Python 3, we can use f strings and prepend an f before using quotes, and then using curly braces and the actual variable name in here. And we need to use the actual variables in here, because otherwise Python wouldn't know. For example, if I use n, it wouldn't know what n is actually. So these are two different concepts actually. But using f strings is actually pretty cool, because you don't really need the dot format anymore, and you can, reference the variables directly in your string. So this makes it a little bit shorter, because you don't really need all this stuff in here anymore. All right, in the last lesson, we had a look at simple variable types that store one value. In the next 3 lessons, we'll have a look at container types. Now, these can store several values, and this is quite important. So we'll start first with the list type. So let's create a list and store several fruits inside it. So let's create another variable called fruits. And to create a list, you use square brackets. And in here, we can now add several elements. So for example, let's add an apple. And to add another element, we use a comma, and then we can simply add other things. So for example, orange and, let's say banana. And now we can print our fruits. And we get all the elements that we have inserted in here. And now there are several things that you can now do with a list. A list is quite powerful and has a lot of functionality to it. So for example, you can add new elements to a list. For that, we can use the append method. So let's call fruits.append. And let's add, for example, cherry at the very end. And we can then again print our list. And you can see here now we have the cherry added at the very end. Now we can also add new elements pretty much everywhere we like. We just need to specify where exactly we want to add this one. So for that, we can use another method called insert. So fruits.insert. And now we need to specify the index where we want to add a new element. So let's, for example, add the new element right between apple and orange. Now keep in mind, lists always start at index 0. So if we need to add a new element between apple and orange, we need to specify the index 1, not 2. Because it always starts, counting at 0. So this is element 0, this is element 1, and we want to add it exactly in here. So insert 1, what do we want to add? So let's, for example, use XXX to make this obvious and insert this value. And we can again print this value. And by the way, you don't really need to use print all the time. You can simply select your variable. So select it and then execute this, and Nuke will then, or the script editor rather, will then execute the value of this variable. So you don't really need to use print all the time. So you see here, we have added this value right between apple and orange. So at index 1. Now we can also double check if an element exists inside a list. For that, we use the built-in functionality in. So how that works is we print. Let's just ask if, for example, apple is contained inside the fruits list. So if print apple, and then we use in, and then our list. And this returns a Boolean. So apple is contained inside a list, inside the fruits list, so we get a true back. But if we, if we, for example, ask for a value that is not contained, then we get a false. Now, we're not bound to just storing strings, of course. We can add all kinds of variable types inside a list. So for example, let's create another list called my things. And we can, as mentioned, add anything we would really like to it. So for example, an integer value. We can, as already seen, we can add strings. We can also add floats and also Booleans. But what we can also do is we can add a list to a list. So that works as well. So for example, we have 1, 2, and 3. So this is a list inside a list. That works as well. And we can continue this, of course. So we can, for example, nest a list in a list in a list. Let's, for example, add a new element, which is a list. And the first element inside this list, let's just say we use the integer 1. But we can now, for example, create another list and, for example, add A and B to it. So we are now effectively saving a list in a list in a list. And we can continue nesting as we need. So let's select this one. And as mentioned, you don't really always need to print the list. You can also simply select a list and execute it, and then we'll get the list value. So that works as well. Now we can also double check how many elements we have inside a list. And for that, we can use another built-in functionality in Python, which is called len, L-E-N. So we can print the length, so len, of and then, for example, our fruits list. And we see that at the moment we have 5 elements contained inside it. So 1, 2, 3, 4, 5. 5 elements. Now we can, of course, also remove an element. So let's see how that works. So let's, for example, say we want to get rid of this XXX. For that, we can use the remove functionality. So fruits.remove. And then we need to specify the actual value that we want to remove. So in this case, it's XXX. And if we remove this value and print our list again, you see XXX is now no longer available inside this list. We can also remove elements by index, and how that works is we use the del built-in, and then we we specify the list and then the index that we want to remove. So let's, for example, remove the first element, which is apple. Fruit, I forgot the S. So if I do that again, and if I print now my fruits, you see that apple is now gone. So this is how we can remove elements by value and also by index. So let's have a look at how our fruits list looks at the moment. So we have orange, banana, and cherry. So we have 3 elements. If we want to print just one element, we can always access it by the index. So for example, if we want to print the first element, we use fruits, and then in square brackets we specify the index. So for example, let's print the first element, which is orange, and the second one, which is banana. So this is how we can use indexes to get one specific value inside a list. We can also, if we don't really know how long the element is, and if we, for example, want to get the last element, we can also do something like this. So -1, which will then, no matter how long this list is, we always get the last element. Or if we, for example, want to get the second last element, we can then use -2, right? And -3, and so on. Now, what we can then also not do, let's, for example, say we want to get the last element. So we start by counting at index 0, 1, and 2. So if we use fruits 2, we get obviously cherry. But if we're now using an index that is not inside this fruits, then we get an index error because we're now accessing something that does not exist. So you can always just specify an index that is actually contained inside this list. So if you're going outside, then this does not work and you're getting an index error. List index is out of range. Now, sometimes you can also use some slices. So let's go back to a larger list. So 1, 2, 3, 4, 5 elements. Right? 1, 2, 3, 4, 5. And if we want, for example, everything from orange and then onto the right, we can use something like this, fruits. And then we can use the index from where we want to start. So for example, 0, 1, 2. So from orange. And then we use a colon. So this gets us all the elements. So starting from this index and then going to the right. So if I execute this one, we get orange, banana, and cherry, which are these values. You can also go, the other way around. We can start from here and get everything from the left. For that, we use colon and 2. Because then we get apple and x. Now keep in mind that this index here does not get returned in this specific example. So if we want to include orange, we would need to go up to 3, and then we have orange contained in here. We can also clear a list. For that, we can use clear. So if I execute this and print my list, then it's empty again. Sometimes we need to count the occurrences of a given element. So for example, let's say we have a list called A, or let's just use some other something, and then we add, I don't know, for example, some strings A, B, A, C, and we want to see how many times this character A occurs here, which is 3. For that, we can use a.count and then the value that we want to count for. So in this example, A. I obviously need the correct variable name. Sorry for that. So we get 3 now. So A occurs 3 times in here, and obviously B and C just once, right? And if we use, or if we ask for something that does not occur, then we get a 0. This does not raise any error. We simply get a 0, which is quite good. Now, sometimes we always need to check where exactly an element exists. So if we want, for example, need the information at which index B exists, we can use something like something.index. And then we ask for the specific value that we want to get. So for example, B, which gets us 1, which again, a list always starts at index 0. So here, index 1, which is where we have this value. Now again, if we use something that does not exist, we get a value error. Y is not in the list. We can also merge lists together. So there are several ways how to do that. And there is something that you definitely need to be aware of, which I'd like to show you now, because if you don't know that, this can cause you some trouble, which is not very easy to see it in the beginning. So let me just show you what I mean with that. So let's have a list, and in here we store 1, 2, and 3, right? And another list. For example, 4, 5, 6. And now let's create a new list and see and update this list. So for example, create a new list, which is A. So we're creating now a new list, C, and this contains the values of A, which is 1, 2, and 3, right? So in order to merge 2 lists, what we can do now is we can use C dot, and then there's a functionality called extend. And then we extend C with B. So if I now print C, we get 1, 2, 3, which is this one. And then we add 4, 5, 6 to it. But if we are now printing A, you can see that we have actually updated A as well. Now, why is that? So that happens because of this equal sign here. What we actually wanted to have is a copy of A, right? But what we have done here with this equal sign, we have effectively created another reference to A. So whenever we update C, we are also updating A. That's not something that we wanted. And sometimes if you're doing that, I mean, this will not be very obvious in the code that you're doing this. So this can really create some not really easy to see trouble down the line. So how do we actually create a real copy of a list? So in order to do that, we use copy, and I'll later show you how you actually work with modules. But for now, let's just do something like this. We use copy, and then what we do is C equals copy dot copy A. So now, let's just start with 1, 2, and 3 again. So C is the value of when copying A. So when we create a new variable, now we are back with having 1, 2, and 3 in C. And now if we are, for example, extending C with the values of B, so let me just copy and paste this. And if we're now printing C, we get these values as expected. But if we're now printing A, we're still left with the untouched list. And this is what we actually wanted to have, right? So whenever we create a copy from a list, we want, in most cases, we don't want to update the values of what we were copying from. So this is something to keep in mind. In the next lesson, when we are talking about dictionaries, I'll also explain something more about this copying, and we'll have some more practical examples where you see copying in action. But just keep in mind, if you want to really create a copy, you need to do it like this. You cannot use an equal sign, because this C will then still reference the values in A, which means if you're updating C, then you will effectively also update the first list, which is A in this example. Just something to keep in mind. All right, this was a little excursion on, creating copies of a list. And in one of the next lessons, we will see how we can iterate over one list and get all elements. But I think it's already a good point to see how that actually works. We will discuss this in further depth in the upcoming lesson. For now, let's just have a look how this works. So for that, we can use for, and then we specify a variable type that we can now use inside one of the so-called loop. We'll get there in one of the next lessons. Let's just create another variable, which is called fruit. And then we iterate over the whole fruits list. So we're iterating over the whole fruits list, and for each iteration, we store the current value in a new variable called fruit. So what we now need to do, we need to use for spaces, because everything that we will now execute, we will execute on the whole list. So let's, for example, print fruit. And if I execute this, you see, so in one of the previous sections, we cleared the fruits. So now if we execute it, we get nothing because fruits is empty. So let's go back to a state where we have actual values inside it. So I selected this line and executed it so that we now have values back inside this fruits list. So if I now execute this, we get the results apple, orange, and banana, which are exactly what we had when we initialized this list. And as mentioned, we will in future lessons talk more about for loops, but I already wanted to show you how you can actually iterate over each and every item and do some stuff with it, because you'll need that all the time. So there's one more thing, or two more things actually I'd like to show you when having a list. It's sometimes quite handy to remove one element and directly work with it. So at the moment, I show you what I mean. So at the moment, we obviously have apple, orange, and banana. And sometimes you want to get access to this element and then immediately remove it, right? So for that, we can use .pop. As simple as that. So if I select this and execute it, this will return the element at the very end. And if I print my fruits again, you see that it is actually removed from this list. So what I can do again is execute it. I get this element now because this is at the very end. And again, if I print this list, I'm left with just element. So let's do that again. I obviously get apple. And now my list is completely empty. And if I do that again, let's see what happens. I get an index error because we cannot pop from an empty list anymore. So we can do that as long as elements are inside this. So this pop functionality is also quite handy, and you will use this quite often when working with lists. Now we can also reverse a list. So let's go back to a full list again. So if I print this list, I'm back with apple, orange, and banana. And we can also reverse the list. So fruits.reverse. And now I can print fruits. And now you see that I started with apple, orange, banana. Now I am in the other direction, banana, orange, apple. So we have effectively reversed this thing. Now we can also sort a list. For that we use sort, fruits.sort. So if I do that and print the fruits, they are sorted alphabetically. So I start with apple, then banana, and then orange, which is also quite nice. So finally, what we can do with lists, we can concatenate these lists back into a string. And for that, we can use the built-in functionality join. And we just need to specify by which character we want to join. So let's, for example, join the fruits by an underscore. So what we can do is now print, and then we specify the character to join by. So we use an underscore dot join, and then we specify the list that we want to use. So in this case, fruits. So we're concatenating all the elements with an underscore and are left with a string. Now, of course, we can also use any other character. So for example, a dot could also do that and pretty much do everything that we would like to concatenate these with. So you see, there is actually quite a lot of functionality to a list, because this is quite an important variable type that you will definitely use day in, day out. In the next lesson, we'll have a look at dictionaries, which is also a very common container type. In this lesson, we'll have a look at dictionaries, which is also a very important variable type that we'll use day in, day out. Now, similarly to lists, a dictionary is also a container that can store several values, but it works a little bit different. So dictionaries is a data type that stores data in a key value pair. It's pretty much like the good old phone book where you have a name, which is the key, and a number, which is the value. So let's have a look how that works. So let's also stay with this example like a phone book. Let's create a new variable called phone book. And to make it a dictionary, use curly braces. So let's open and close and indent by 4 spaces. And let's add some keys. So for example, James has the number 200. Let's add another key value pair. So for example, Tom equals 355. Sarah has 179, and let's add one more key value pair, which is, for example, Julia, who has 55, right? So let's execute this one, and let's print the phone book. So you see here, we get all the key value pairs, like James 200, Tom 355, and so on and so on. Now, since Python 3.7, so meaning Nuke 13 and above, dictionaries are ordered. In previous versions, they were unordered. So what does that mean? If I created a dictionary in a previous Nuke version, so in Nuke 12 or below, and printed that one, like I did here, for example, this key value pair here could be anywhere else, and the same applies to any other key value pair. So the order was not really stored. That changed with Python 3.7, and dictionaries are now ordered. So the order in which you insert them, the order gets saved, right? Also interesting to note that key value pairs or keys are always unique, and you cannot have a key twice. Actually, if you create or if you add a key value pair that is already there, the previous value gets overwritten. So let's see how that works. So let's, for example, use Tom again, and here we used 355. Let's put in 1000 and print the phone book. And you see here, Tom has now 1000. So always make sure that you don't use a key value pair or a key more than once. You can, of course, use different values. So here in this example, I always used integers, but you can use anything else. So let's create another dictionary and just call it something. This is just for demonstration purposes. Does not really have any meaning. So let's use another key hello and assign a float to it. So 1.2, for example, and let's create another key, and let's, for example, store a list inside it. And another key, we can we are not limited to only use integers. We can also use other variable types, but they need to be mutable, and I'll come back to this in a second. But what we can, for example, do is use, for example, an integer like 5 and assign the value true, so a boolean to it, and another one, I don't know, house, sorry. And what we can also do is we can nest a dictionary inside a dictionary, of course, right? So we have this dictionary, and in here we have this key house, and we store another dictionary inside there. So let me expand this. So A1, B2, and so on. So this is also valid. We can store other variable types as values. As mentioned, I will come back to the key values in just a minute. So we store this. Let's get back to this phone book in here. And how do we access the actual value? Well, what we can do is we call our variable type phone book and we specify the key. So for example, let's get the number for James. So phone book James, and this is 200. Now what we can't do, we cannot access values that are not there. So if I do, for example, this one, this key does not exist in here, I get a key error that because XXX is not inside this phone book. What we can do, and we pretty often need that, because when adding a dictionary, we add things, so key value pairs on runtime. And in some situations, we don't really know what is in there, but we can safely ask for this one, for XXX, without raising a key error. So how does that work? Well, we use .get and we replace the square brackets with round brackets. And if I get that, if I execute that, we get a none. We can also print this value, so you better see that. So this is a none. So this is a safe way to get the value if it exists. If it doesn't, then we'll return a none. What we can also do is return a default value in case this one here, get, and then the key does return nothing. So for example, some fallback value. And now I get some fallback value printed because this key XXX does not exist in here. Right? So this is again my phone book. What we can also do is clear the phone book, so clear the dictionary. For that I use phone book.clear. Oops, I misspelled that. Let's simply copy paste that over. So I have now cleared it, and if I print my phone book again, you see it's empty. Let's get back to a dictionary that has some values. We can print all the keys inside a dictionary. So all the names, for example, here. What we do for that is phonebook.keys. And in Python 3, this returns a dict keys type, which works pretty much like a list. In a previous Python version, or in Python 2, we returned a list, but this behaves pretty much the same. So what we can do now is, so for example, for name, in keys, print name. And you see here, we can return all the names, all the keys rather. We can also do the counterpart. We can print all the values. So values. And you can see here, we print all the values. We can also combine both so that we get the key and the value. For that, we can write down for name and then number. So these are the local variables that I will have in my for loop. So name, number in phonebook dot, and then we use items. And what I can do now is I can print the name and the number. So for example, 0, which will be the name, has the number 1, and I format the string. And 0 is the name and 1 is the number. So you see here, James has the number 200, which is this one here. Tom has the number 1000. This is because we overrode it, right? So this value here is not existent anymore. and so on and so on. So this is how we can loop over the keys and the values, something that you'll use quite often. We'll also see later how we can store this dictionary, or pretty much any dictionary, to a text file, which is also a pretty common thing. For that, we'll use JSON, which is the standard file format for a dictionary, to store a dictionary onto disk. We'll see that in a later lesson. So let's come back to the actual type that we store here in a dictionary. A dictionary can store not only can not only use strings as a key, you can use pretty much anything that is immutable. So what does that mean, immutable? Well, in Python there are several variable types which are mutable and immutable. So let's, for example, see what we can do first. So let's use another variable type called something. And let's use an integer as a key, which we've also done here. And store, for example, a string, hello. And we can also use a float and store, for example, a Boolean. What we can also do is use a Boolean as key and store, for example, false. And what we've done so far, using a string and store, for example, 1 and 2. True, 1, 2, 3, 4, 1, 2, 3, 4, right? We have now all the key value pairs in here. And what we can now do is, or rather, what we can't do is, let's expand this dictionary and use, for example, a list as a key and store, for example, hello to it. So if I execute this one, I get a type error, unhashable type list. Now, what does that mean? So when creating a dictionary, you can only use immutable variable types as a key. And since a list is mutable, you cannot use that as a key, which is some interesting detail to keep in mind. So how do you exactly know what variable type is mutable and what variable type is immutable? You can simply test that. So let's have a little look at how a string actually works under the hood. So if I have the string a, which has the value hello, right? What we can do is we can print the ID of this variable a. For that, I can simply use print ID and the variable name. And here you see some cryptic ID. Let's now change this variable type. So for example, a equals a plus exclamation mark, and print the ID again. And you see here that the ID itself has changed. So what does that mean is, if we add anything to a string, then this will, under the hood, create a different variable type, a different, or rather a new variable. So if I execute this again, we have this ID ending with 432. Then we add to this string, and then we print the ID again. And you see here it ends with 136. So it effectively changed. It is actually a different variable now. So Python allocated new memory for it. Let's do the same for a list. So my list equals, I don't know, just some random values, and print the ID of my list. We get this value here, and let's add to that list. So append, for example, 4, And let's print the ID again. And you see here it ends with 7280, 7280. So this is the same value. So although we added to this variable type, the ID itself stayed the same. And this is what I mean with mutability and immutability. So lists themselves, when you add values to it, the ID stays the same, meaning the variable itself stays the same. So you cannot use lists as a key because you could, for example, add something in here and Python wouldn't know that this actually changed this key. In the next lesson, we'll see how we can use a different type, which looks pretty much like a list, but is mutable, which is the tuple. But we'll come back to this in the next lesson. So one final thing I'd like to show you for dictionaries is that at some point you will stumble upon this issue, or rather this behavior, and I wanted to show you what is really going on here. So let's copy this dictionary in here, right? So let's say we want to create a copy of this phone book. So new phone book equals phone book, right? So whenever we change any value in here or in here, the other dictionary updates as well. So let's see that in action. So let's say, for example, let me just copy that over. New phone book, and let's say, for example, James equals, so the old value was 200. Let's use 6,000. So we updated the new phone book, right? Let's print the old phone book. So the value in here changed as well. So let's also just print just this value. So print, print just this value. So you see here, in both cases, the value changed. Now, why is that? So the equal sign does pretty much a new reference on the other variable. So if I create a new variable, new phone book, we actually reference the values in here. So every time we change something in here, this also changes the original phone book. In order to create rather a real copy of it, what we can do is we use copy. So let's see how that works. For that, I'll need to import something, and we'll later have a look how imports work. Let's simply just use this keyword import, and then this is a module, which is called copy. So as we're doing this, we have now functionality of this copy module. And what we can do here is create a new phone book, and the value of new phone book equals copy.copy phone book. So if I now change a value in the new phone book and print my old phone book, let me see 1 second. I did one mistake. My mistake was now that I still printed the old value that I got from this example. So what we rather need to do, sorry about that, sorry for the confusion. Let's first initialize the phone book again, right? So I have James 200. And now I'm creating a new phone book by using copy.copy phone book. And assign a new value to James in the new phone book. And let's now print the old phone book. And you see it stays the old value. So if I print my new phone book and my old phone book, you see that these values here are different. So here we kept the old value and here we effectively replaced the value. Now copy.copy does a so-called shallow copy. What that means is it only copies objects on the first level. Let's have a look at another example to see what that really means. So let's pretend we have another value, which is now not a simple variable type, but also a dictionary, but it could also be a list. So some nested value structure, some nested container. So let's say we have the value A, which is 1, and the value B, which is 2, right? So we have this phone book, which has now another container inside it. And if I now create a new phone book by using copy.copy phone book, let's just copy this over in here, right? So if I now use new phone book, and if I access now another, and say, for example, A should be, let's use 999. So let's print the new phone book. And we see we updated this value, but let's also print the old phone book. And you see we have the same problem. Now, why is that? So as mentioned, copy.copy does a shallow copy. So it copies only elements or objects rather on the first level. If you really need a real copy of nested things, then there's another thing which is called copy.deepcopy. So let's create, or let's rather reset the phone book so that we have A1, B2. And in order to create a deep copy, we use copy.deepcopy phone book. So we have now a copy, which really copies everything nested. So if I now change this value in here on my new phone book, if I now print the phone book, you see the value in here stayed the original value. Whereas if I now print my new phone book, the value is the new value that I assigned. So again, to recap, if we use the equal sign, this is rather just a reference, meaning if we edit one of these, the other one does get edited as well, because we're just referencing from via another variable type. Then there is copy.copy, which copies on the first level. But if you really need a real copy, also with nested copy elements, then what you need to do is using copy.deepcopy, because this creates a real copy of your nested container. This is a little side effect that this is something, or rather in the beginning, not very obvious, but I just wanted to spend a minute explaining what is going on here and how you can prevent from creating some weird behavior where you change a value and you're wondering why the other variable also changes. This might be the reason for that. All right, that's it. Enough for dictionaries. And in the next lesson, we'll have another look at sets and tuples. In this lesson, we'll have a quick look at another container variable type called tuple, which is similar to a list but has some important differences, which we can sometimes become quite handy. And we'll also have a quick look at sets. So tuples are immutable, unordered, and unindexed. Let's have a look at what that means. So let's create another variable called a. And to make it a tuple, we use round brackets. So let's, for example, store 1, 2, and 3 inside it. And then we can print our tuple. And we see we have these values. So this looks pretty much like a list, what we've seen in previous lesson. But we're not using square brackets. We're now using round brackets. And if I double check the type, we see that this is a tuple. This is not a list. So let's quickly explore all the functionality that a tuple has. So for that, as seen before, we can print year of tuple. And we see there is less functionality to a tuple than compared to a list. And if you look closely in here, there is no append functionality. So that also means we can, for example, not do something like this. So a.append, let's for example, append 4. If we do that, we get an attribute error because a tuple does not have such a functionality to append something. So that means we can create tuples, but we cannot actually add some values to it. Now you might be wondering what's up with that. Sometimes this can become quite handy, and we'll have a look at this in just a second. But let's just quickly discuss these two methods, so count and index. So these are functions that are also available with lists, which we've also seen. So I can, for example, do count. Let's say, for example, we count 2 and we get the number of 2 that appears in this list, in this tuple here. So 2 occurs just once. So if we, for example, initialize this with another 2, and then we count for the value 2, we get 2 occurrences of 2, which makes sense in here. Right? So we can also return the first index of a given value. It's also something that we've seen with lists. So we can, for example, do a.index and then, for example, get the first index of 2, which is in this case index number 1. So if you remember, lists but also tuples, they always start with the index 0. So the first time this value here occurs is index 0, index 1, which you see here as well. So back to our question, what can we actually do with a variable type that we cannot change? So in our previous lesson, we had a look at dictionaries. And as mentioned, we cannot use mutable types in there. So for example, if we have some variable, some dictionary called my map, and the key is, for example, a name. So this would be the first name, and this would be the last name of the user, and this user has, for example, this value. Right? If we execute this, this does not work because a list is a mutable type, meaning we can add some values to it, but it's still the same. It still has the same ID. So that's where we can actually use tuples. So if we copy this line and make this a tuple instead, then this works. We can use this one, right? So we can now store this one here. This is the tuple. We can store this one, or we can rather use this one as a key. So this can become quite handy. And this is the only way how we can use container types as a key, by using a tuple. So all in all, there's not too much more to discuss with tuples. They're pretty much like lists, but you cannot add any values to them, but they are still quite useful. For example, for this use case in here. Now let's have a look at another container type, which is a set. Now a set stores always unique values. So for example, if we have another variable called b, and if we want to create a set from it, we can do that by using curly braces. So this looks at the moment like a dictionary, but there's a little bit of a different format to it. So you will now store values directly inside these curly braces. So if you recall, dictionaries look a little bit different. You always have a key, then you have a colon, and then you have the value. In here, this looks, the content itself looks like a list, but you're not using square brackets, you're using curly brackets, right? So if I execute this and ask for the type of B, this is now a set, right? And as mentioned, one unique feature about sets is that it can only store unique values. So for example, if we are adding several times this value 1 and execute this and print this one, then we're still left with unique values. So 1, 2, 3. So 1 just occurs once. It's like these duplicates get cut off. This can become quite useful. For example, if you want to get rid of all duplicates in a list. Let's say, for example, we have a list, and here again we use square brackets to make it a list. Let's store, for example, A, B, A, C, and A again, and maybe also B again, so that we have duplicates of A and B, right? But now if we create or if we cast this to a set, then we will actually get rid of all the duplicates. So for example, set and name. Oh, sorry, I need to execute this first, of course. So now we are left with just unique values, so A, C, and B. And you can already see that sets are also unordered, like tuples. So what we can do now is we can concatenate this with another functionality. So for example, we can sort this. But before doing that, let me first check the type of this one. This becomes, of course, a set. We can cast the set back to a list, right? So we can do something like this, and then we get back a list. And now let's finally sort this one so that we have A, B, and C. For that, we can use sorted. And we get a list which is sorted and has only unique values, A, B, and C. So these are two other very common container types, the tuple and the set. And this pretty much wraps it up with container types for now. In this lesson, we'll have a look at different ways how to iterate over elements in a container like lists and dictionaries. Now, this is yet another fundamental concept that you'll definitely need day in, day out in your code. So we already have had a quick look at how to iterate over elements inside lists and dictionaries in a previous lesson, but let's have a look at this in a little bit more detail. So let's start with a list. Again, for example, doing something like fruits and storing some values in it. So for example, apple, orange, and banana. And in order to iterate over this list, we can use the built-in keyword for, so for, and using now a local variable name. So let's, for example, call it fruit. And in this case, it also makes sense, or you should also pay attention to make this a singular noun, because we now want to iterate over single elements, right? So for fruit in fruits, and then in the next line, it's quite important that you indent by 4 spaces, 1, 2, 3, 4, because now everything that is indented gets executed with each and every iteration. So let's, for example, print fruit. And when we execute this, we see we're printing all the elements, so apple, orange, and banana. Now, just to demonstrate the importance of the indentation, let's, for example, also print another thing. So, for example, just some dashes in here. And as I have indented this, this will now be printed with each and every iteration. So when I execute this, you can see we're printing the first item in our list, and then we're printing a dash. Then the second item and a dash, and so on and so on. So it really makes a difference if you're indenting or not. Because, for example, if we're just doing this, we unindent, then we're telling the Python interpreter to loop over the whole fruits list, printing the element, and then at the very end, print a dash. So if I execute this, you can see the exact result in here, printing all the elements, and at the end, printing a dash. So pay attention if or if not you need to indent the code. Everything that is indented gets executed with each and every iteration. Now, oftentimes it is quite useful to also print the actual index of the element. So if we recall, lists always start at index 0. So let's, for example, say we want to print 0 apple, 1 orange, 2 banana. And for that, we can use a concept which is called enumerate in Python. But first, before doing that, let's first have a look at how you can also achieve that, but it is actually not that efficient. But it's actually still quite important to mention that. So let's see how that works. We can create another variable called index and set it to 0. So, and then we again write a for loop. So for fruit in fruits. And what do we want to do now? We want to print the index and the fruit. So I've seen before, when executing print, we can actually specify several things, and they will then all get executed in one line. So when I execute this now, you see we're printing the index, but it always stays at 0. So we need to do one more thing. We need to increase the index. So we can use index equals index plus 1. And when we execute this, now we get the needed results. So 0 apple, 1 orange, 2 banana. We can actually simplify this. So index equals index plus 1 is the same as writing index plus equal 1. This is the same result, but a little bit shorter. So this is the inefficient way of how to do that. And you always see, or quite often see that, when some programmers from other programming who come from other programming language are doing that. In Python, there's a more effective way, and this is called using enumerate. So this is how it works. We're again writing a for loop, but now we're already specifying the index and the local variable name. and then we use enumerate. And inside enumerate, we specify our list fruits. So we're calling this enumerate on fruits, and this actually gets or returns us the index of one specific element and the element itself. So we can now again do print index and fruit, and when I execute this, we get the very same result, 0 apple, 1 orange, and so on. But this is way cleaner, way shorter, and way more efficient than using this concept in here. Now, if you need, you can also use a different start value. And by using a comma and then as a second argument, you can, for example, start with 1. So at the moment we start with 0. Let's execute this one. And you see here we're starting with 1 and then counting up. Sometimes that's helpful to start at a different index. Now we also had a look at how we can loop over dictionaries. So let's quickly recap this. So let's, for example, again, use a phone book and store some values in it. So for example, James 200 and Tom gets, let's say again, 355 and Sarah 179, and let's just add one more element. So for example, Julia gets 55. So these are all the numbers. And then as seen before, we can iterate over the keys and the values and the keys and the values. So again, to do that and then we specify the local variable name. In this case, let's first iterate over all the names. So for name in phone book, print name. Oops, one typo. Print. So in here we're printing over all the keys. So in this case, these are the names. So this is the same as doing phonebook.keys, but you don't see here it's the same result, but you don't need to write down keys. So if you're just using for name in phonebook, then this will already be translated to just iterating over all the keys. We can also iterate over all the values as we've seen before. So the numbers. In this case, let's rename this variable to number. And when I execute this, we get all the numbers in here, as seen here. And as also seen before, we can iterate over the name and the number, so the key value pairs, by using writing down two variable names. So this one will be the local variable name for the key and the local variable name for the number, for the value. And for that we use phonebook.items. And then we print the name and the number. And then we get exactly what we have in here. So the name and the number for every element inside this dictionary. Now, interestingly enough, you can also iterate over strings. So let's have a look at this, for example, on the element Marla. So this is a string, Marla. Then I can do the very same as we've done before in here. So and let's, for example, call each and every thing in here character. For character in name, print character. So and you see here, we are printing each and every character because a string is pretty much a container that stores single characters in here. Now, besides using for loops, there's another concept of iterating over containers. For that, we can also use a while loop, but this is something we will just see in a minute. You need to be careful with that. So how that works is, let's, for example, iterate over the numbers 0 to 9. For that, we can start with an index. Let's start it with 0. And then we can use the keyword while. So while some condition occurs, we will execute something. So we've seen this with Booleans before. We can use we can write down some conditions. So for example, while index is smaller than, for example, 10, we will then print the index. Now, when executing this, you need to be very careful as we're not increasing index. This would effectively end now in an endless loop. So just be careful not to execute this right now, because we first need to increase the index. Otherwise, as mentioned, we're ending in an endless loop. So if I execute this, we iterate from 0. We start from 0 and then up to 9. So please note that we're not including 10. So if we want to include 10, we actually need to write 11, right? So this is how we can use a while loop. With each and every iteration, it double checks again if this condition here still occurs. But you need to be quite careful to always increase your counter, because otherwise you will end up in an endless loop and this can crash your program. So in often cases, you're pretty fine with just using 4, and this is way more safe to do. Another thing that we can use to print out some numbers is using range. I call range, and for example 10, we get a range object that starts from 0 to 10. And I can also do, for example, something like 5, 10. Then we are creating a list that starts from 5 and ends at 10. Or it's not actually a list, it's a range object. But we can use this range object in a for loop. So as seen before, we can use for number in range 10 and then print the actual number. So if I execute this, we are printing from 0 to 9. So again, this does not include the 10 itself. So if you need to print 0 to 10, then you need range 11, right? So and as seen before, we can also specify a different starting value. So for example, let's count from 5 to 10. And we can do so by using range 5 and then actually 11, because this number here will not be included. Let's go back to 10 to just print from 0 to 9. And sometimes it is quite useful to skip a certain element when some condition occurs. Let's see how that works. So let's just copy and paste this. So let's say, for example, if we are at number 5, then we don't want to print this. And how we can do this is we can simply continue to the next number then, and pretty much skip the number 5. And how we do this is we will have a look at if structures in an upcoming lesson. Let's just for now already use this. So if, and then we need to write down the actual condition. So for example, if the index is 5, what do we want to do then? We want to skip. And as we're now in a for loop, we need to indent by 4 again. And this if statement also needs some indentation. So we again need to indent by 4, 1, 2, 3, 4. So this is now the indentation for the for loop, and this is the indentation for the if loop. So if the index is 5, then we continue. And this means we will then skip this current element that we're iterating over, and we're starting over again from the top and continuing with 6. So when I execute this, you see we're iterating or printing rather the actual values, and 1, 2, 3, 4, 5, and we see there is one. This number here shouldn't be printed actually. Let's execute this again. If index equals 5, then we continue. For number in range 10, if index equals 5, then we continue and don't print this number. This is quite interesting. This shouldn't actually happen. If index equals 5, then we continue. So this number here should actually not be printed. This should never happen actually. What is going on with that? 2, 3, 4. 1, 2, 3, 4. This was a very stupid mistake. Sorry about that. So why did this number here print? Well, the reason is we're using totally different variables in here. So we are creating a local variable in here, number. But in here, we're checking if index. So this is a variable from a totally different context. So what we rather need is if number equals 5, then we continue. So this was actually quite interesting that I put that in here. I didn't pay attention to that, but this is also something that you always need to double check if actually your variable names are correct in here. So if I execute this, you will get the correct result because 5 is now not printed here anymore. So sorry about that, but this is also you know, some mistake that you probably sometimes stumble over. You're simply forgetting some very obvious things in here. Anyway, we can use continue to skip one element or several elements. Whenever this condition here occurs, then we will actually continue with the next iteration and double check if this here again is true or false, and then handle accordingly. So this is how we can use continue. Now there's another thing which is called break, and break is also a very often used concept. So with break you can stop the whole list. So let's see how that works. Let me quickly just copy and paste in here. So we're iterating over the numbers 0 to 9, and when the number 5 gets hit, then we don't want to continue. We want to break out of this loop. So let's see how that looks like. So you see here after we're printing 5, we're now or 4 rather, we're now hitting number 5, and this condition now is true, and then we're breaking out of the whole loop. So we will not continue as seen here. We will not continue. We will break out the whole loop. So everything after that will not be executed anymore. And this can sometimes be quite handy to, you know, simply stop a loop when some condition is secured. So for example, think about, you know, searching for specific elements in a list or something. So as soon as something gets found, we are fine. We don't need to iterate over a list anymore. We can simply then skip the whole iteration and continue with our code. So this is also very helpful. There's also another concept with break. We can also double check if when we are iterating over a list, if or if not, we have broken out of this iteration, meaning if we went cleanly through with iterating over all elements, or if we needed to break out of the loop. And for that, we can use the keyword else. So let's finally have a look at this one as well. Let me quickly copy and paste to make this a little bit quicker. So for a number in range 10, when the number is 5, then we will break out as seen before. Whereas when we don't break out, we will then, for example, print did not break anywhere, did not oh, sorry, I need quotes, of course, did not break anywhere. So when I execute this, you see we are breaking out of the loop when we're hitting the number 5, right? But when I now comment this code, we will actually not break out of this, and we will print each and every number in here. And as we don't break out of this loop, this else statement, and we also needed to indent here before, this else statement will get executed. So when I execute this, you see in here, did not break anywhere. Whereas again, when I use a break, we don't print this line. So meaning we don't execute this line actually. Again, if I comment this in here, we are executing this line. So this is sometimes really helpful to double check if we broke out of the loop or if we didn't, because then we can handle this specific event where we did not break out of the loop. So that's it pretty much for a more in-depth look at how we can iterate over containers. In this lesson, we'll have a look at a technique called list comprehensions. Now, list comprehensions are a really handy way of creating a list from another list in a concise way. List comprehensions might look a little bit complicated in the beginning, but once you get the concept, it's actually quite straightforward to use them. Because also list comprehensions are a technique that you will definitely use quite often. So let's have a look at how that works. So let's start with our fruits example again and store some fruits in a list. So for example, apple and orange and banana and cherry. And I capitalized these last two elements here on purpose, because now we would like to create another list that contains only these lowercase elements, so apple and orange. So how do we do that? Well, in the previous lesson, we've seen that we could, for example, use a for loop and then check some condition. And only if this condition occurs, then we will append these values. So let's have a look. So, and write a for loop. So for fruit in fruits. And before doing that, let's actually create a list. So lower fruits. And so for fruit and fruits, and as seen before, we can double check if a string has only lowercase by using is lower. So if we recall, when we're doing some dir on a string type, we see that there's a functionality called is lower, which we can use now. So if fruit dot is lower. So what do we want to do then? We want to append this value to our lower fruits. So lower fruits dot append and then the fruit. Don't need that anymore. So when I now copy and paste this one, when I now execute this, we can see that we are now storing apple and orange in our new list lower fruits. Now, this took quite a few lines to write this down. And we could actually do that a little bit shorter with using a list comprehension. So let's have a look at how that works. So let's use the same name, lower fruits equals, and then we can use the following syntax. So we're iterating over the whole fruits list, and similar to here, we're using a local variable name. This looks like this. So fruit for fruit in fruits. So we're iterating over the fruits list and using this local variable name, and we're adding this value in here. So the local variable we're adding to lower fruits. So when executing this and double checking our lower fruits, we are actually left with a copy. So each and every element of our original fruits list got added into here. But we don't want to add these two elements. So we need some condition similar to what we've done in here. We only want to add the element when fruit is lower. So when it only contains lower characters. And we can simply add this in here. So if fruit dot is lower. So when I execute this and print my lower fruits again, we are left with the very same result that we had in here, just apple and orange. So when we count this one here as well, because we're initialized an empty list, we need 4 lines in here, whereas here we just need 1 line to write the very same thing. So this is way more concise and a way cleaner thing. Now you will oftentimes see people who come from another programming language or who just started with programming with Python, who don't really know this concept of list comprehensions yet. You will sometimes see people doing that, but this is actually not really the preferred way of creating a list from another list. Using list comprehensions is definitely the more concise and preferred way. And this is also something which is called, it is more Pythonic, which means we're using the features in Python as they are intended to be used. So this is some really great feature in Python that you don't really have in other programming language. Now this is not very readable. What is better to read is if we're splitting this into several lines now. So let me do that. So I pressed enter and indented it by 4 spaces so that we know that this is one block in here. So fruit for fruit and fruits. And then I put the if statement in the second line and put the square bracket at the very end in here. So that we are left now with this block, which is when I execute it, it gets us the very same result, but it is a lot more readable because in here we're adding all the elements. In here we're checking for the condition to only add the element when this condition occurs in here. Now, similarly, we could also do another list that contains only these elements, and there are now 2 ways of doing that. We could either do pretty much the same in here, so not checking for is lower, but some functionality to check if it is capitalized, which you'll see in a second, or we can also double check if any element that is not contained in this lower fruits. So let's have a look at both of these options. So let's call it capitalized fruits. And what is capitalized fruits? It is again fruit for fruit in fruits. If fruit dot, and what is now the functionality? Let's quickly double check. So if I do another dir on a string, you see there is no is capitalized function, but what we have in here is there is an is title. This is exactly the functionality that we need. So if fruit dot is title, let me remove that. We don't need that anymore. So when I execute this and print the value, we see here we get banana and cherry because we are adding every fruit in our fruits list that has this condition here set to true. So when fruit is title, which means is title is when the first letter is a capital letter. Now the alternative way would be to simply double check and get every element that is not contained in this fruits in here. So let's do that. So capitalized fruits equals and then use square brackets again. So fruit for fruit in fruits. And what do we want to do there? We want to double check if fruit is not contained in lower fruits. So let me copy that one. So if fruit not in lower fruits, because then we're iterating over fruits and we're only including elements that are not contained in lower fruits, which is these are the lower fruits. So we're effectively adding everything, these two elements, so because they are not in lower fruits. So when I execute this and print my capitalized fruits, we get the very same result in here. So these would be two different ways of how we can actually get the capitalized fruits. But this one here only works, of course, if we have already done this step in here. So it takes a little bit of time to get used to list comprehensions, but it's a really, really effective way of creating lists from another list. In this lesson, we'll have a deeper look at if statements. Now, we have already briefly touched if statements in previous lessons, but let's spend some more time on these, as if statements are a fundamental concept in programming. Now, using the if statement, we're checking if a given condition applies, and only if it does so, then we will execute some code. And since we check if a condition applies or not, we can use a Boolean for that, as there's only a true and a false state. So to illustrate that, let's create two variables, a equals 1 and b equals 2. And let's actually compare the values of these two variables. So let's print a is equal to b and double check if that is actually the case. So as previously seen, to compare things, we can use two equal signs in here. So remember, if you're just using one, you're assigning a value to a variable, as seen here and here. But if we want to compare two variables, then we can use two equal signs. So a equals b. And when we print this, we see a is equal to b, false, right? Because a has the value 1 and b has the value 2. So pretty simple. So let's actually check if they are not equal. So a is not equal to b. And for that, we can use the exclamation mark and an equal sign. So that means this checks if a is not equal to b, meaning if the values are not equal, right? And this returns true, which makes sense because a has a different value than b. So we can compare things, and only if these things apply, then we can execute some code, which we can now see how we can do that using an if statement. Before that, let's first visualize that we are going right inside a for loop. So let's simply print start. And then we can use, as seen before, we can use the keyword if, right? So if a equals b, or sorry, let's first check if a is higher than b, right? Then we can execute some code. And as seen before, we indent by 4 spaces. And then we print a is higher than b. And when we execute this, we see start, and we actually don't go inside this if statement because a is not larger than b. A is actually smaller. So if we also print that we have finished our if statement, and if we execute this again, you see we are executing this line, we are executing this line, but as this condition does not apply, we are not executing this line. So with that, we can drive behavior inside our code. So just to demonstrate this, if we make A larger than B, and when we execute this, we can then, or we will then execute A is higher than B, which makes sense. Now, of course, you can enlarge this if section and do any other thing. So, for example, doing something else and print another, and these are then also executed, of course, because everything you can see here doing something else and another, everything that is indented in 4 spaces by 4 spaces will be executed. Whereas if I change this logic around, if I make A smaller than B and execute this, then you see nothing in here gets actually executed. Now there's also another thing to keep in mind. You can also use an else. So execute some code only when a given condition does not apply. So let's see that in action. So let's again use if A larger than B, which is in this specific example not the case because A is smaller than B. So let's print A is higher than B. And again, if we execute this, nothing gets executed because this condition here does not apply. But when we're, for example, doing else, so if this condition applies, execute this. Otherwise, go into this block in here. And this is also indented, of course. So we can say A is smaller than B, right? So this gets executed at the moment. But let's see, for example, when we are making them both equal, let's execute this. This does actually not apply anymore. So we should rather do something like if A is smaller than B, then we print, and let me just copy this one here. And so when A is larger than B, then A is higher than B. When A is smaller than B, then A is smaller than B. And else, so the last condition would be when they are equal, right? So A and B are equal. So let's execute this one, and we see in here A and B are equal. And let's double check that this if statement here works. So now A is smaller, so we should print A is smaller than B, which is the case. And when A is larger than B, double check. Result A is higher than B. So this is again another thing to keep in mind. So why does A and B are equal get printed in here? Well, the reason is that the logic is followed as seen here. So when A and B are, when A is larger than B, then we execute this code. But when A is smaller than B, then we execute this code. But when this condition here does not apply, then we will execute this section. This is actually not what we want. And this brings us to another concept, which is called if-elif. So if we're writing if-elif, then if this condition here is true, then we're executing this. But when this one here is not true and this one here is also not true, then we will execute this, right? So there is a fundamental difference between writing it like so, if condition do this, if condition do this, else. This one here gets executed just if this block in here, if this condition is not true. But what we actually want is we would like to only execute this one if both of these conditions are not true, right? So for that, we use elif. And now if we execute this, you see A is higher than B. That's the case in here. Let's do A smaller than B. Yeah, A is smaller than B. And let's make both equal. And now A and B are equal. So this is how if, elif, and else works. And what you can also do is adding several more elifs in here. So in this example, there are just 3 possible scenarios, right? But you could also, do some do some pseudocode in here. You could execute something else, or elif another condition applies. You can then, execute something else, but only execute this section in here if none of these conditions apply. Let me just remove that. So what you can also do is you can nest if statements inside if statements. Let's have a look at how this works. So for that, let's create 2 more variables, a equals 1 and b equals, for example, 10. And let's first check if a is higher than 0, which is at the moment the case. So what do we want to do then? Well, we can use another if statement. So for example, if b is smaller than 20, for example, and then as we're now having a second if statement, we of course need to indent again so that we have 4 spaces and 4 spaces. We've seen this before. So only if both situations are true, then we print, for example, OK. So let's execute this. And you see we're printing OK because both situations apply. But let's, for example, say, so here we're checking if a is larger than 0. So for example, if we make this -1, then we will no longer print this, right? We take this back. And when we, for example, need to execute this, of course, otherwise the values don't get assigned. If I now, for example, say b is 30, then again, we don't execute this because this if statement here is no longer true. So we will not execute this code in here, right? Now, you should be aware that this is not really a good style of programming. You should really keep your indentation as low as possible because, let me just demonstrate this. Let's say we have, for example, when these both conditions apply, then we're using, for example, a for loop for n in, let's say, just numbers. I don't want to initialize these values in here, but let's say we're, for example, then, checking another thing if n is larger than 5, for example. So, and then only then do something. So you see already, let me just make this indentation right in here. So you see there is quite a lot of overhead going on in your head to double check when exactly you will execute this line. So yeah, okay, a needs to be larger than 0. Okay, b smaller than 20. then we're going in a for loop. So visually in my mind, I'm now in a for loop, and I need to keep in mind that I have a local variable n. And now I'm checking, yeah, is n higher than 5? So there is actually quite a lot of things going on in your head when you think about when exactly does this line get executed. So you should definitely avoid this. This gets really, really quickly complicated. So definitely keep your indentation as low as possible. And there are certain ways how you can do that. We will also see that over the course. I'll show you just one thing that, or two things actually, that you can do to avoid these things. Because usually when you're doing this, this is obviously a sign that your code is too complex and could be separated into different functionality to make this a lot cleaner and a lot easier to read and also to maintain. Right? So let's remove this and talk about how we can double check 3.4, how we can actually improve this and use less indentation. So in this case, as we're executing two if statements, we can also do that in one line using the and keyword. So let's see how that works. So if a equals, or a is higher than 0, we can also concatenate certain condition checks, if you will. So for that we can use the and keyword, and then we can simply use another or check another condition. So be smaller than 20, and then we want to print OK. So when we execute this, let's simply execute both in here. You see in both cases this is fine, but whereas, for example, when we're increasing the number to 30, then we will no longer execute this in both situations. So these are now behaving the same, but this is a little bit more readable than this because you have less indentation in here. Now you can also do something else. You can check if either this condition here applies or if this condition here applies. And for that you can use the, let me copy and paste this one here. You can use the or keyword. So print OK when A is higher than B, or when B is smaller than 20. So when I execute this, we print OK, because this one here is already true. So this section here will actually not be executed anymore. This is a little trick for Python to be a little bit faster. So as soon as it hits some condition that applies, and when it sees or, then it will immediately execute this in here. So let's say we use -1, because then this section here will actually be false. But as B is 10, this one here will still be true, and we will then still execute OK, right? So this is how we can use and or. And sometimes in your code you will need to double check if A has, for example, the value 0 or 1 or 2. So double checking if it has actually one, or it is using one or another value. So let's see that in action. So let's say we have A equals 1, and let's double check and see if A is either 0 or 1 or 2. And as seen before, for that we can use or. So if A equals or is 0, or we don't need an if in there, of course. If A is 1, or A is 2. What do we want to do then? We can, for example, print a is quite small, right? And if we execute this, we see this gets executed because, let's see in here, we assign the value 1 to a. So this one here does not apply. This is false. But this one here applies. So after this gets detected as true, this one here will no longer get executed. The Python interpreter will immediately jump into this line and execute it, right? So for example, if we're now doing -1, then nothing will be executed. And the same for example, 3, exactly. But if we're using any of these values, then this will be executed. Now, this is also a little bit problematic, and we can do better. We can, for example, double check if the value a is in one specific range or in a list or tuple. So let's see how that works. So to get the very same result, we can actually print if a in, and then we can, for example, use a list and initialize the list with some values. So 0, 1, and 2. And when that's the case, let's copy this one here and execute it. And at the moment, a is 2, so this should now be printed. And you see in here, a is quite small. Let's do -1 and execute this one here, and this does not get executed anymore. So this is a little bit more readable and also shorter. And just to make sure that this is a list, so as seen before, we could potentially add values to it. Just to make this a little bit safer, let's actually compare to a tuple, because we cannot, on runtime, we cannot add any values to it. So this is a little bit more safe to execute actually. So let's increase this, for example, to, I don't know, 1 again, and execute, and this prints then a is quite small. Now there's another concept which I show you now, which can also dramatically increase the readability of your code. So let's say in some situations you need to double check if any condition applies. This is pretty much the same as here, that sometimes you don't have the chance of double checking if a certain value is has a or is in a specific tuple or list. Sometimes you just need to double check if checking something is true or checking another thing is true. So let me just show you what I mean. So let's initialize a with 1, b with 2, and c with 3, just to keep this simple. So let's say we want to check if a equals 1 and b equals 2 and c equals 3, and then we want to print, for example, OK. So at the moment, this should print OK, right? Because all these conditions apply. But this, again, is pretty hard to read. What you can do instead is you can check if all of these conditions apply using the all built-in keyword. So let's create another list called conditions, and we initialize it with the following value. So a equals 1, and this is actually a Boolean value if you recall, because we are using 2 equal signs. So b is 2 and c is 3. So when I execute this one and when I execute this one, you see in here when I print all the values of condition condition, actually, as this is a list and stores several values, we should rather call this conditions. It's a little bit more precise, actually. So when we execute this, we see that, writing a equals 1, which is a comparison, this actually returns a Boolean value, so true. And this one here is also true. Let's, for example, just for demonstration purposes, increase this to 20 and execute the conditions again. And you see in here, B is no longer 2 because now it changed to 20, right? So we get true, false, true. Let me revert this so that we are left with true, 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 right? And now, as we have now a list of Boolean values, we can apply the all keyword. So if all, and all takes a list, and in here we can say conditions. So if all conditions, then print OK. And this is quite more readable because if you compare it with this one here, yeah, this one here uses a little bit more lines, but it's actually, for me, it's actually pretty much simpler to read, because here I need to double check, yeah, is that one true? Yeah, okay, is that one true? Okay, yeah, is that one true? Let's pretend there are several more conditions that we need to double check, and only if that one here, if all of these are true, because we're using a true in here, then we will be executing this one. So this line in here, it could be potentially a lot longer. And the longer the line, the harder, or the more time it takes to read and understand this. So I would always try to keep lines as small as possible, because then you can really easily read this. So here we always need to mentally be in an if statement, right? We need to check something. Is this one here true? Yeah. Is this one here true? Is this one here true? Then only double check this. Whereas here we initialize a list, and we simply initialize it with some values. That means also, when I execute this again, we can now double check for each and every value if it actually applies. And this makes also debugging a little bit more simple, because we can now immediately check if this condition here applies. We have no chance of knowing in this line if this one here is actually true or false, and the same with this one and with this one. So this makes it a lot easier to double check, the logic that you're writing in here. So when we execute this again, we see, oh yeah, this is true, true, true. So this line here is always true, because we are only using true values in here. So when using all, this will only become true when all conditions in here, when all items in here, which are these ones here, when they are true. So again, let's execute this, and we see this one here becomes okay. Whereas when we, for example, increase one value in here and execute this again, then this will not print okay anymore. Right? So there's a counterpart to all, which is called any. And this is pretty much like the or that we've seen in here. So when any condition applies, so either this one or this one or this one, then we will execute some code. So let's see that in action. If any conditions, then print OK. So when I execute this one, then we see this one here is OK. And when I increase, for example, C to 30, then let's actually execute the initializing of the conditions, and we see we get true, true, false, because C is no longer 3, but still, because we're using any in here, we will actually print this line. Whereas when we're using all, not everything, as seen here, not everything is true. So when I execute this one, you see in here, this does not get executed. So this is this is a pretty cool concept to, increase your readability, because you can, if you see that here one, you can pretty much read this as plain English instructions, right? So if any conditions apply, then execute this one. Whereas also, if all conditions apply, then execute this one. This is way simpler to read and understand than, doing something like this. So always keep in mind to use all and any when you would like to double check if certain or if several conditions actually apply. In this lesson, we'll have a quick look at some often used built-ins inside Python. Now, built-ins is a functionality which is always available as it's simply part of Python. And you might not have noticed it, but we have already used quite a lot of Python built-ins. So for example, format and print and lang and all and any. So let's have a look at how to get an overview of all built-ins and discuss these further. So for that, in another lesson, we'll have a look at imports. For now, let's simply use import and then built-ins. And then inside built-ins, we find all the built-in functionality. So for that, we can use print dir and then built-ins, which gets us everything that is inside built-ins. And you see this is a list of quite a lot of things. So to make this a little bit more readable, let's actually loop over all the built-ins inside a for loop and print these one by one. So let's, for example, use a local variable called, let's say, use it built-in. So for built-in in dir built-ins, because as seen here, dir actually returns a list, so we can simply iterate over it, and then let's simply print the built-in. So when I execute this, you see we get a long line, a long list of all the built-ins that are available inside Python. And you see there are some things that we have already discussed. So for example, apps, the we did not have that one. I meant that one here, all and any, right? So for example, to get an overview of what, for example, apps does is we can simply print some help on it. So help apps. And you see using apps and then some value returns the absolute value of the argument. So let's see that in action. So for example, apps 4, that returns 4. But also when we are using a negative value, then this will also return 4. So we always get the absolute value, which is the positive value, no matter if the input is negative or positive. Let's go back to this list. And you see there are quite a lot of things in here. So I encourage you to just play around a little bit with it and have a look, as we previously seen, just doing some, some help on, for example, let's say, what does that one here do? Help bin. Return the binary representation of an integer. Okay, that's interesting. You get some binary value for that. Okay, never used that actually. So there are actually quite a lot of a lot of built-ins that you will definitely use day in, day out, but there are also some things that you will probably never use or quite not very often. Just missing the word in here. Not very frequently, I wanted to say. So I encourage you to just play around a little bit with it and have a look what is available inside it. And the reason why I think this, having a look at built-ins is important is to give you one special hint about not using any of these words in here as a variable name, because this can change the behavior of your code. So let's see what that means in action. So when I go, for example, in here, you see len is also a built-in. So if we recap with len, we can get the length of or the number of elements inside a list. So let's, for example, say we have a list of 3 elements, 1, 2, and 3. And if we print len, we get the number of elements in here, right? We've seen this before. So as this one here is a keyword, a built-in keyword inside Python, you should not use this as a variable name in your code. Let's see what happens when we do that. So let's create another variable called len and, for example, assign the value 4 or hello or anything, pretty much anything to it, right? So we now have assigned this integer value to a variable called len, which is valid. You can do that in Python, but the problem becomes now obvious when you actually want to execute the built-in functionality len of a list. So what does that return? It gets us now a type error because an integer, which is the value that we assigned to len, is not callable. We will have a look at functions in one of the next lessons. For now, what the Python interpreter would do is it would try to execute a function on an integer, and this does not exist. So keep in mind not to use any of these keywords in here as variable names. Don't do that, because then you will alter functionality and things start to break and will not work anymore. So how long does this len now exist as an integer value in here? Well, as long as our Python session lasts, which is in Python in Nuke land, as long as Nuke is open. So as soon as we close Nuke and reopen it, then we have len back as the default built-in functionality to actually calculate the overall numbers of elements in a list. So, but as we have now overwritten len, as long as this Nuke session here lasts, we will now be stuck with this value, unless we explicitly override it again, of course. So just keep that in mind, that don't use any of these built-in keywords as any variable name. All right, that brings us to the end of this week. So this week we covered many basics in Python, but these are the essential building blocks for everything upcoming. So to quickly recap what we did in week 1, we had some background information about why Python is actually a good choice and what you can do with Python. Then we had a look at how to access Nuke's script editor. And we also covered a little bit of background information about Python 2 and Python 3 and had some practical examples of what actually changed between Python 2 and Python 3. Then we had a look at the print statement, also something that's very important in Python, actually in all programming languages, being able to print something to the console. Then we also covered how to write single line and multi-line comments to comment your code, and also had a look at some best practicing when it comes to commenting your code. Afterwards, we had a look at simple variable types, so strings, ints, floats, and booleans, and had a look at common things that you can do with these variable types. Then we had a look at how to use format strings to resolve a variable inside a string, and all the different ways how you can do that. Then we started having a look at container types, so lists, dictionaries, tuples, and sets, and also had a look at common functionality that you will use day in, day out on these container variable types. Then we had a look at list comprehensions to create lists from another list in Python, and we covered for loops and also while loops and range, and had a look how we can break out of a loop and also skip one specific element using the continue built-in. Then we had a look at if-elif-else data structure or logical structures, how to use them, and also had a look at some commonly used Python built-ins. Now, before wrapping up this week, I would like to give you a little assignment so you can play around with Python and have a little challenge to solve yourself. In the next week, we'll then discuss how to implement the request. So in this week's assignment, I would like you to create a phone book with some entries, so storing a name and a number, which we've seen before. And then ask the user about a name, and this should then return the name. This should then return the number, of course. So we haven't had a look at user interaction so far, but I would like to give you some hint. So we can create another variable, and the value of it is getting the user input. And with that, we can use nuke.getInput. And in here, we print the label that gets that appears inside a dialog. So let me quickly show you how that looks like when I execute this, and we will have a look at these user interactions in upcoming lessons. So this one here, enter a name, that is the label that appears in here. So for example, when I insert Peter and press OK, then this value is already stored in my name. So here I can now refer back to the input or the value that the user entered. And as soon as the user executes this again, and let's say, for example, put in Sarah, now Sarah is stored inside the name variable. So with that, we can now loop over our phone book and print the number that is associated with that entered name, if it exists. Now, in case the entered name does not exist in the phone book, then I would like you to give some notice to the user that the entered name is not found in the phone book. The search itself should be case insensitive. So no matter if the user inputs, for example, John or John in lowercase or here with a capital character, then it should in both cases return the same value. So as a little hint, you will need to double check how you can do that. So you will need to do some operation on a string. And for that, you can again use a here and then string. And double check and, for example, trying out different things and see which one of these here gets you the lowercase version of a string. So for example, let's say we think that it's this one here. We can simply do a help on, for example, and for that one, we need to use string.zfill. And you see pad a numeric string with zeros on the left. It seems this is probably not what we want. So I encourage you to go a little bit over this list and try to find out how you can actually make a lowercase version of a string. And we will have a look at the implementation next week, but I would like you to try this out on your own first. So see you next week then.